Beneath the eternal twilight of the southernmost skies, where the wind howls like a warning through a silence older than time itself, lies a world few have ever seen, and even fewer truly understand. Antarctica, a continent cloaked in ice and secrecy. At first glance, it's nothing but a frozen wasteland. But look closer, and you'll find something far stranger. Buried beneath layers of ancient ice are anomalies that defy explanation. Perfectly geometric structures hidden in satellite scans. Fossils of tropical plants where no warmth has touched in millions of years. Unmarked metallic objects detected beneath the surface, deep enough to predate human history. And eerie, magnetic disturbances that stretch across the continent with no known source. Some say it's just geology. Others whisper of long-lost civilizations, covert experiments, or remnants of something not meant to be found. What is Antarctica really hiding beneath its frozen silence? And why are some discoveries being quietly dismissed, forgotten before they're even understood? So sit back, relax, and let's dive into the icebound enigmas of the last true frontier, where science meets secrecy and the Earth itself keeps its oldest secrets buried in the cold. In the heart of East Antarctica, where the icy winds sweep endlessly over a desolate, white horizon, lies a region known as Wilkes Land. It's a remote, inhospitable expanse, untouched by human settlement and largely concealed beneath thousands of meters of ancient ice. To the untrained eye, it's no different from any other part of the continent, silent, frozen, impenetrable. But deep beneath its surface, hidden under nearly 2 miles of glacial crust, something is stirring the instruments of geophysicists. Something vast, something unknown. It's called the Wilkes Land Anomaly. First detected in 2006 by NASA satellites conducting gravity measurements, the anomaly revealed itself not to the eye, but to the math. A subtle but persistent gravitational distortion, an immense mass buried below the ice, stretching over 300 kilometers across and plunging several kilometers deep. It creates a magnetic pull so strong that even the Earth's gravity field registers its presence. In the world of geophysics, this kind of deviation is not common, and in Antarctica, where so little has been mapped or studied in depth, it's extraordinary. At first, researchers assumed the anomaly might be linked to an ancient impact crater. Satellite imaging data seemed to show a circular structure, an indentation in the Earth's crust that resembled known impact sites around the globe. Some proposed that a massive asteroid, perhaps twice the size of the one that wiped out the dinosaurs, may have struck here around 250 million years ago. The timing is eerily close to the Permian-Triassic extinction event, the greatest mass extinction in Earth's history, which saw over 90% of marine species and 70% of terrestrial life vanish. Could the impact in Wilkes Land have been the trigger? It's a compelling theory, one supported by structural patterns, gravitational modeling, and the presence of ring-like features beneath the ice. But as with all things in Antarctica, confirmation is elusive. No drilling has reached the depth required to sample the area directly. The ice remains unyielding, the evidence buried in silence. Others propose less dramatic, but still significant, explanations. Perhaps the anomaly is the result of an ancient tectonic structure, an upwelling of mantle material, or a long-buried mountain range lost beneath the shifting plates of Gondwana. Antarctica, after all, was once part of a vast supercontinent, lush and forested. Could this be a geological scar left from the time before the ice? But there are other, more speculative whispers, theories that drift at the edges of scientific consensus. Some fringe researchers believe the Wilkes Land anomaly might be something else entirely, an artificial structure, a remnant of a lost civilization, or something not of this Earth. They point to the perfect circular shape, the symmetry, the strange magnetic signatures. They ask questions mainstream science hesitates to entertain. Could this be the remains of a colossal man-made complex, long frozen over? A subterranean base, a forgotten city, or something older than humanity itself? In recent decades, Antarctica has become the focus of a new wave of theorists, drawn to its inaccessibility and shrouded history. From stories of Nazi expeditions during World War II, to Cold War rumors of hidden technologies, to satellite images showing strange patterns in the snow, Antarctica has become a canvas for speculation. The Wilkes Land anomaly, enigmatic and perfectly placed, only fuels that fire. Of course, no evidence exists to support these theories. No tunnels, no machines, no ruins. Just readings, numbers, gravity maps, abstract data sets translated into ghostly images on a screen. Yet, it's the absence of certainty that allows the mystery to breathe. The lack of answers keeps the door open, however slightly. One of the most curious aspects of the anomaly is the silence around it. Despite its significance, the Wilkes Land anomaly rarely makes headlines. Few scientific missions have followed up on the initial discovery. Budget constraints, logistical challenges, and the sheer difficulty of drilling through Antarctica's frozen crust all contribute to the delay. But to some, the silence itself is suggestive. What if someone already knows what lies beneath? It's a question that lingers, unspoken, among the data points. As the wind continues to howl over Wilkes Land, the anomaly remains untouched, undisturbed. Whatever lies beneath the ice, be it asteroid, mountain, or monument, has waited for millions of years. It will wait longer still. And so we're left with a shape, a signal, a mass, a gravitational whisper from deep beneath the ancient ice. We know it's there. We can measure it, but we cannot yet touch it. Could this be the scar of a cosmic cataclysm, a geological relic of Earth's forgotten past, or something else altogether? The answers lie frozen in a place where questions gather like snow, layer upon layer, year after year, awaiting the day someone finally dares to dig deep enough. Just beyond the gravitational riddle of Wilkes Land, deeper still into the frozen silence of Antarctica, lies another enigma, less massive, but no less profound. If Wilkes Land is a mystery of stone and ancient impact, then this is a mystery of water, sealed in darkness for millions of years. It begins beneath Russia's Vostok station, a remote outpost perched atop the East Antarctic ice sheet, one of the coldest places on Earth. Here, in an environment so extreme that even bacteria struggle to survive, lies something astonishing: a hidden lake, one that exists not above the surface, but far below it. Entombed beneath nearly 4 kilometers of ice, untouched by sunlight for as long as 15 million years, Lake Vostok is the largest known subglacial lake on the continent, and perhaps the most mysterious. Discovered in the 1990s through radar imaging, Lake Vostok stretches over 250 kilometers in length and contains as much water as Lake Ontario. Yet, its isolation is total. No rivers flow in. No light shines through. The pressure is immense, the darkness absolute, and the temperature barely above freezing. It should be lifeless. And yet, it may not be. When Russian scientists drilled into the lake in 2012, after years of preparation and international caution, they did so with extraordinary care, wary of contaminating the pristine ecosystem below. What they retrieved wasn't just water. The samples contained microscopic life, bacteria, unknown species, organisms that had never been seen before, and whose DNA didn't match anything cataloged in existing databases. Could these life forms have evolved independently for millions of years, sealed off from the rest of Earth's biosphere? Could they hold clues to the adaptability of life, or even to life beyond our planet? Some researchers believe so. Lake Vostok, with its dark, pressurized waters and extreme conditions has become a model for extraterrestrial habitability. It resembles, in many ways, the icy moons of Jupiter and Saturn, Europa and Enceladus, where oceans exist beneath frozen shells, hidden from starlight, warmed by the friction of tides and the heat of planetary cores. If life can persist in Lake Vostok, cut off from the sun and the surface for epochs, then why not on Europa? But not all findings are easily explained. Some of the recovered DNA fragments were so unusual, so anomalous, that they seemed to fit nowhere in the known tree of life. One set of sequences matched only 86% of known organisms, far below the threshold typically accepted for anything familiar. Russian scientists described them as possibly belonging to a new type of bacteria, or something entirely unknown. Were they contaminants, misreadings, or did the lake truly contain a lineage of life completely separate from anything we've ever encountered? The debate remains unresolved. Further complicating the mystery are the physical features of the lake itself. Unlike most bodies of water on Earth, Lake Vostok is capped not just by ice, but by an active thermal dynamic. Heat from the Earth's interior keeps it liquid beneath the ice, and sediment layers at the bottom suggest a history of chemical reactions, volcanic interactions, and shifting geology. Some have even speculated about hydrothermal vents, fissures on the lakebed that could mimic the deep-sea vents of our own oceans, where life clusters around plumes of heat and minerals in total darkness. If vents do exist in Lake Vostok, then the possibility of a self-sustaining complex ecosystem becomes more plausible. Still, access to the lake remains limited. The original drilling operation halted before fully breaching the water column, and subsequent efforts have proceeded slowly, constrained by funding, international environmental treaties, and the sheer technical challenge of boring through miles of ice without compromise. In this vacuum of certainty, the mystery has grown. Some fringe theories suggest that Lake Vostok may hold more than biology. Stories have circulated, unconfirmed and largely speculative, about strange structures detected near the lakebed, about magnetic anomalies, about unexplained readings in the water. Some have gone so far as to imagine ancient ruins beneath the ice, or remnants of lost civilizations preserved in the cold. These ideas are largely dismissed by mainstream science, and yet they persist, fed by the absence of information and the allure of the unknown. Why has so little exploration followed the initial discovery? Why is the lake, with all its potential, still largely unstudied? The reality may be mundane. It is simply too difficult, too expensive, too politically sensitive. But for those drawn to the edges of discovery, those unanswered questions echo louder than any explanation. And so, Lake Vostok waits, silent beneath its ceiling of ice, isolated from the sun, from sound, from time, a sealed capsule of Earth's deep past, or perhaps a preview of other worlds yet to be reached. What lives in those waters? What secrets sleep in the sediment? Are we looking at the origins of life, or at something altogether new? In the stillness beneath the Antarctic ice, we may be standing on the edge of the most extraordinary biological discovery of our time, or simply staring at the last great mirror of our own uncertainty. As we journey further into Antarctica's frozen heart, past the buried secrets of Lake Vostok and the invisible mass beneath Wilkes land, we come upon a sight so startling, so visually out of place, that it defies the monotony of white. Amid the towering glaciers of the McMurdo Dry Valleys, one of the coldest, driest deserts on Earth, there is a stain on the ice, a cascade of deep red that spills from the frozen cliffs like an open wound in the glacial face. This is Blood Falls. Emerging from the snout of the Taylor Glacier, Blood Falls is a rust-colored outpouring of liquid that seems, at first glance, almost supernatural. Bright against the surrounding blue-white expanse, The flow appears to bleed from the ice itself. It is a scene that has confounded and captivated explorers since it was first discovered in 1911 by the Australian geologist Thomas Griffith Taylor, who believed at the time that red algae were responsible for the striking coloration. But as we now know, the truth is stranger still. The crimson hue of blood falls is not biological in origin, but geological. The liquid is a brine, 5 times saltier than seawater, rich in iron that oxidizes upon contact with air, much like rust. This ancient, iron-laden water has been trapped beneath the glacier for over 1 million years, sealed in a pressurized, oxygen-deprived reservoir beneath the ice. When it seeps to the surface through fissures in the glacier, it meets the atmosphere and transforms, turning a vivid, blood red as the iron reacts with the air. The scientific explanation is elegant, and yet it raises more questions than it answers. How does liquid water persist in such an extreme environment where temperatures often fall below -40 degrees Celsius? How has this brine remained isolated for so long, undisturbed, unfrozen, and alive? Because there is something alive in blood falls. Samples taken from the subglacial brine have revealed the presence of microbial life. Tiny organisms thriving in complete darkness, in conditions toxic to most known life forms. These microbes feed not on sunlight, but on sulfate and iron, sustaining themselves in what was once believed to be a sterile, lifeless environment. Their survival points to the incredible adaptability of life, and to the possibility that Earth is not the only planet where such extreme ecosystems might exist. If life can endure beneath the Taylor Glacier, in a chemical soup sealed away for over 1 million years, then perhaps similar forms of life could exist beneath the icy crusts of Europa or Enceladus, or even deep within the Martian permafrost. Blood falls, in this sense, is not just a curiosity. It is a window into alien habitability, a natural laboratory for astrobiology. Still, some aspects of the phenomenon remain puzzling. The brine system beneath the glacier is vast and interconnected. Magnetic readings and radar scans have revealed an intricate network of subglacial channels and reservoirs, hidden rivers that flow beneath the ice. These systems are active, dynamic, and still largely unmapped. No one knows how deep they run. No one knows how old they truly are. And then there are the more speculative ideas, whispers at the edge of the scientific narrative. Some researchers have noted anomalies in the glacier's behavior, unexplained pulses in brine flow, sudden changes in temperature within isolated pockets, magnetic disturbances near the source. While many of these readings have logical explanations, subsurface pressure shifts, mineral interactions, or instrumentation errors, others remain uncertain, ambiguous enough to leave room for interpretation. Over the years, theories have emerged. Some propose that the brine may conceal entire microbial ecosystems, complex, interdependent, and ancient. Others suggest that the iron-rich outflow could be a clue to a deeper, older process taking place beneath the Antarctic crust, one that predates the glacier itself. More fringe thinkers imagine blood falls as something symbolic, perhaps even a warning. They point to its unnatural color, its persistence, its location in the dry valleys, one of the few places in Antarctica not buried by snow. To them, it feels almost like a signal, a red mark on a white canvas, a message from the Earth's deep past. But what would it be saying? To scientists, blood falls is a phenomenon of immense research value. To poets and philosophers, it is a haunting contradiction, a place where life emerges from death, where warmth trickles through cold, and where something as lifeless as a glacier can bleed. It stands as a reminder that Antarctica, for all its silence, is not static. Beneath its surface, the continent breathes. It shifts, flows, and remembers. And sometimes, It reveals things we are not prepared to see. What lies further below the Taylor Glacier, in the tangled veins of subglacial water and iron? How many more ecosystems remain, locked away in ice, waiting for release? Could there be life forms there that are older than humanity? Or mechanisms at work that challenge our understanding of biology, chemistry, and the Earth itself? As the red stream continues to bleed across the frozen ground, it offers no answers, only questions. And in Antarctica, sometimes a question is the only thing that survives the cold. As we move from the crimson flow of Blood Falls, where iron-rich water bleeds mysteriously from glacial ice, we come to a different kind of enigma. One not hidden beneath Antarctica's surface, but drawn, painstakingly, and with apparent precision, on the surface of aged parchment. In a quiet corner of the Topkapi Palace Museum in Istanbul, preserved behind glass and centuries of speculation, lies a map. Torn, faded, and incomplete. At first glance, it appears much like any early 16th century maritime chart. But look closer, and you'll notice something that has puzzled historians and scientists for decades. A shape, a landmass, a coastline that shouldn't be there. This is the Piri Reis map, drawn in 1513 by the Ottoman admiral and cartographer Piri Reis. The map is an amalgamation of older source materials, some of which, he claimed, came from the time of Alexander the Great. What makes it so remarkable is not just its age or the detail it displays in a time before global navigation, but what it appears to depict: the northern coastline of Antarctica, but not as we know it today. The map shows a landmass south of the equator, beneath the tip of South America, a rugged coastline free of ice, with bays, inlets, and mountain ranges that seem to correspond, at least roughly, with modern seismic maps of Queen Maud Land, as it would appear without its ice sheet. This is where the mystery begins. Antarctica wasn't officially discovered until 1820, over 300 years after the Piri Reis map was drawn. Even then, it remained largely unexplored, locked in ice and nearly invisible beneath its frozen shell. And yet this map appears to show the continent not only known, but ice-free. How could that be? Some scholars argue that the landmass on the Piri Reis map has been misidentified, that it is merely an exaggerated or distorted representation of South America, or perhaps a mythical southern continent, common in the speculative geography of the time. After all, early mapmakers often filled in the unknown with artistic flourishes or based their coastlines on hearsay and older legends. But others are not so sure. In 1960, the U.S. Air Force cartographer Charles Hapgood proposed a radical theory. After studying the map's geographic features, he concluded that it matched the subglacial topography of eastern Antarctica with surprising accuracy. More than could be expected from guesswork. Hapgood suggested that this was evidence of ancient source maps created before the continent was covered in ice. Before Antarctica froze, over 6,000 years ago, or perhaps much earlier. According to this theory, the original knowledge behind the Piri Reis map might have come from a lost civilization, one capable of mapping coastlines with a level of precision not seen again until the age of satellite imaging. Could such a civilization have existed? One with seafaring ability, astronomical tools, and geographic understanding long before the rise of recorded history? Mainstream historians are cautious. They point to inaccuracies in the map, inconsistencies in scale, and the lack of corroborating evidence for such advanced pre-Ice Age cultures. Many believe that the resemblance to Antarctica is simply coincidence, or that the map's coastline is misinterpreted. After all, early maps were often compiled from multiple, overlapping sources, some accurate, others purely speculative. But the anomaly remains. The Piri Reis map continues to hover in the gray space between cartography and mystery. Adding to the intrigue are the map's origins. Piri Reis himself claimed to have used more than 20 older charts, some from ancient seafarers, others from Arab or possibly Greek sources. What were these maps? Where did they come from? And why have they vanished? The idea of a preserved memory, of ancient knowledge passed from culture to culture, distorted through time yet never fully lost, has long fascinated those who study forbidden or forgotten history. Could the Piri Reis map be a remnant of that memory? A cartographic echo from an earlier world? Others take the mystery even further. They question whether Antarctica was always covered in ice. Geological studies have confirmed that Antarctica's climate has shifted dramatically over the millennia. During the Pliocene, around 5 million years ago, parts of the continent may have been ice-free. But no human civilization is known to have existed at that time. Unless, of course, there's something we've missed, something buried. Satellite imaging of Antarctica has revealed strange geometric formations beneath the ice, structures that some claim are too regular, too angular to be natural. A pyramid-like shape here, a grid-like pattern there. Are these simply geological formations distorted by the play of shadow and snow? Or something else? The Piri Reis map is silent on the matter. It offers no explanation, no legend, no compass for the anomalies it may, or may not, contain. But its presence lingers in the world of unexplained history. A fragment, a suggestion, a map that seems to know more than it should. Could an ancient mariner have glimpsed the shores of a warmer Antarctica? Could an unknown culture have passed its knowledge through the centuries, only to be rediscovered in a time unready to understand it? Or is the entire mystery an illusion, an accident of shapes and shadows, stitched together by our desire to find meaning where none exists? The parchment remains unchanged. Its lines still trace an impossible coastline. And in the cold silence of Antarctica, the land it may describe sleeps beneath a mile of ice, waiting, perhaps, for someone to draw the next map. From the mysterious coastlines etched into ancient maps to the frozen silence of the continent itself, Antarctica has long resisted simple answers. It guards its secrets well, under ice, under time, and sometimes above our very understanding. Because here, at the bottom of the world, scientists have detected something truly strange. Not a shape, not a structure, but particles, fleeting messengers from far beyond our planet. High on the Antarctic plateau, where the snow stretches flat and blinding beneath a sky untouched by pollution or sound, sits a device called ANITA, the Antarctic Impulsive Transient Antenna. Suspended from a balloon flying more than 35 kilometers above the Earth, this high-altitude experiment was designed not to look outward into space, but downward, through the Earth itself. Its mission? To detect high-energy cosmic particles, specifically neutrinos. These ghost-like particles are some of the most elusive in the universe. Trillions pass through our bodies every second without leaving a trace. They are nearly massless, rarely interact with matter, and originate from the most violent cosmic events: exploding stars, colliding black holes, even the birth of the universe itself. Most neutrinos pass through the Earth entirely undisturbed, but occasionally a high-energy neutrino will collide with an atom, triggering a cascade of secondary particles. It is these interactions that ANITA seeks to detect, by capturing the brief radio bursts emitted as the particles slam upward through the Antarctic ice. But in 2016, ANITA picked up something unexpected, twice. Instead of detecting neutrinos coming from space and passing through the Earth, the experiment recorded signals that appeared to originate from within the Earth and travel upward. As if something incredibly energetic, something unlike any known particle, was bursting out of the ground. This was not what the laws of physics predicted. Neutrinos of such high energy shouldn't be able to pass through the Earth at all. not without interacting, not without being stopped. Yet these anomalous detections suggested otherwise. Something, either a particle that shouldn't exist, or one that breaks the rules as we know them, was behaving in a way that demanded explanation. So what exactly did Anita detect? The scientific community responded with caution. Some theorists proposed that the events might be due to previously unknown interactions involving tau neutrinos, one of the 3 types of neutrinos known to physics. Others considered more exotic options: sterile neutrinos, supersymmetric particles, or errors in data interpretation. Yet none of the standard models fit easily. The upward-pointing signals defied the basic framework of how we understand high-energy particles. What made the puzzle even stranger was that a separate Antarctic observatory, IceCube, a neutrino detector buried deep in the South Pole's ice, had not recorded the same events. Though sensitive to similar phenomena, IceCube remained silent. For some, this discrepancy added to the mystery, and as happens with all anomalies that resist easy explanation, the speculation soon began to widen. What if these were not just rare particles, but something entirely new? What if the source wasn't astrophysical, but artificial? Could these events point to unknown technologies operating beyond our detection? Could they be signs of matter or energy passing between dimensions? Or, most controversially, could they be evidence of something extraterrestrial? The term alien particles quickly took root in headlines and online forums. It's a phrase loaded with suggestion, often misunderstood, sometimes misused, but in this case, it reflects a very real scientific mystery. Not alien in the cinematic sense, perhaps, but alien to our current models, alien to the standard model of physics, alien to everything we thought we knew about how the universe works. To be clear, no scientist claims that these particles prove the existence of intelligent life, but they do suggest that our understanding of the universe may still be incomplete. That perhaps, under the ice of Antarctica, we are seeing not a hidden civilization, but the edges of a hidden physics. Why is it always here, on this continent of extremes, that our instruments encounter the inexplicable? Is it the purity of the ice, the isolation from interference, or something deeper, something encoded into the land itself? What's especially compelling is the pattern emerging across Antarctic mysteries. Not just ancient maps, buried lakes, or magnetic anomalies, but now, invisible particles piercing up through the Earth, as if trying to tell us something, trying to show us a flaw in our assumptions, a door we haven't noticed. In a place where almost nothing can survive, we may be glimpsing some of the most elusive truths about the cosmos. And yet, the data remains sparse. The signals are few. The interpretations still debated. Are these anomalies hints of a new class of particles, misread atmospheric events, or brief flashes from a realm of physics we haven't yet mapped? As the Antarctic winds whistle across a land of ancient ice, the mystery lingers. The answers, if they exist, are as silent as the particles themselves, passing unnoticed, unfelt, until one leaves a mark, until one breaks through. Just as the invisible messengers of the cosmos challenge our understanding of physics beneath the Antarctic skies, the secrets buried deep in the ice tell a different kind of story. One not about the future, but the deep, forgotten past. Beneath Antarctica's thick white crust, where silence reigns and temperatures rarely rise above freezing, lies a world that seems almost impossible. Not a cavern, not a fossilized ruin, but a forest. A rainforest, lush, green, ancient, entombed under more than a mile of ice. In 2019, an international team of scientists drilled into the ice of West Antarctica near the Amundsen Sea, in a region thought to be completely inhospitable to complex life. What they pulled up was astonishing. A core sample containing a dark, compacted layer of sediment that wasn't just rock or ice, but soil. Preserved within it were fossilized roots, pollen grains, and even remnants of wood. Tiny, microscopic clues that painted a radically different picture of Antarctica's past. Roughly 90 million years ago, during the mid-Cretaceous period, Antarctica, it seems, wasn't the frozen desert we see today. It was warm, temperate, covered in dense, swampy rainforest, a land where conifers, ferns, and flowering plants thrived in rich soil, where rivers flowed beneath a canopy of trees, and where dinosaurs roamed in the shifting twilight of polar seasons. How could such a landscape exist at the bottom of the world? At the time, the continent was still connected to parts of what would become Australia and South America. It sat closer to the South Pole than it does today, yet was far warmer, likely due to a combination of high atmospheric carbon dioxide levels and a global greenhouse climate. The world was different then. Sea levels were higher. There were no ice caps at either pole. And yet, even in months of darkness, the rainforest endured. The discovery is more than a curiosity. It reshapes our understanding of climate, of geology, of life itself. It forces us to ask how a region now defined by ice could once have supported such vibrant ecosystems. How life not only existed, but flourished in a place where modern assumptions say it shouldn't have. And what else might still be buried beneath that ice? The fossilized forest beneath Antarctica is not a single grove or isolated patch. Signs of ancient vegetation have been found in multiple regions, East and West Antarctica alike. Petrified wood, leaf imprints, even traces of insect activity. In some cases, coal deposits suggest vast stretches of dense jungle that thrived for millions of years before being slowly swallowed by advancing glaciers. But what caused this shift? What turned rainforest into wasteland? Around 34 million years ago, Earth underwent a dramatic transformation. The warm greenhouse world began to cool. Antarctica drifted further south, and as ocean currents shifted, the continent was cut off from the warmer waters of the tropics. Ice began to form, slowly at first, then with growing intensity, until the entire landmass was buried beneath kilometers of snow and ice. The forests froze, the rivers vanished, the soil locked away in silence. Still, some questions remain unanswered. How much of this ancient world remains intact beneath the ice? Could entire ecosystems lie preserved in the cold, waiting to be revealed? What kinds of organisms might have adapted to that transition, surviving the freeze in microbial form or fossilized in perfect detail? Even more curiously, some researchers have found signs of geothermal heat beneath the Antarctic crust, pockets where volcanic activity warms the land from below. Could these regions have preserved more than soil and pollen? Could they harbor clues to evolutionary branches we've never seen? Life forms that diverged in isolation, beneath the growing ice. In recent years, satellite imaging and radar mapping have revealed a more dynamic Antarctica than once imagined, crisscrossed by subglacial lakes, mountain ranges, and buried canyons. Could these hidden landscapes hold traces of the ancient rainforest? Or perhaps even remnants of something older, something predating human history altogether? And then there are the more speculative interpretations. Some fringe theorists suggest that the discovery of ancient forests points to a lost chapter in human, or pre-human, civilization. If Antarctica was once temperate, could it have supported intelligent life? Could mythologies of lost continents, Atlantis, Mu, Lemuria, have been inspired by dim ancestral memories of this green southern land? There is no evidence for such claims, but the idea persists, fueled by the sheer scale of what remains unknown. What we do know is that Antarctica is not a static wasteland. It is a continent in motion, historically, climatically, geologically. A place that once breathed with warmth, life, and growth, a place that remembers. And now, with ice melting faster than at any time in recorded history, those memories are surfacing. The soil, when thawed, still carries the scent of ancient vegetation. The pollen, under a microscope, glows with colors that have not been seen in the open air for 80 million years. What else might lie waiting, silent beneath the weight of time? Could there be seeds still preserved in the permafrost? Could they one day be revived? Or has the past been locked away too long to return? In Antarctica, the line between past and present blurs with every core sample, every seismic scan. The ice is not just a blanket, it is a vault. And somewhere in its depths, the echoes of a lost forest still whisper beneath the frost. As we move deeper into Antarctica's buried past, from ancient rainforests to long-lost climates, we come upon a mystery not of what once grew here, but of what still stands, silent, immense, and unseen. Beneath the heart of East Antarctica, far beneath the thickest ice sheet on Earth, lies one of the most astonishing and elusive mountain ranges ever discovered. A range as large as the Alps, with peaks that soar more than 3,000 meters high, yet not a single one breaks the surface. These are the Gamburtsev Mountains. Named after Soviet geophysicist Grigory Gamburtsev, this hidden range was first detected in 1958 during a Soviet expedition using seismic instruments. The data revealed a dramatic and unexpected landscape: jagged peaks, deep valleys, and plateaus frozen in darkness for over 30 million years. For decades, the existence of these mountains remained little more than a ghostly imprint beneath the ice. A rumor in the data, a shadow on a screen. But as technology advanced, so too did our view of this forgotten world. In the early 2000s, an international team of scientists conducted a vast geophysical survey using ice-penetrating radar, gravity readings, and seismic measurements. What they uncovered was breathtaking: a complex alpine mountain system larger than many surface ranges on other continents. Entire watersheds, glacial basins, steep ridges and broad plateaus, untouched by wind, rain, or erosion for tens of millions of years. And yet, the biggest mystery wasn't just how the mountains had remained preserved beneath the ice, it was how they got there at all. According to most models of plate tectonics, mountain ranges form when two landmasses collide, pushing rock upward in dramatic fashion. But the Gamburtsev Mountains are located at the center of an ancient continental craton, far from any active plate boundaries. Their presence is inexplicable. There's no clear sign of a collision zone, no recent fault lines, no apparent reason for these mountains to exist. So, how did they form? One theory suggests that the mountains are very old, perhaps over 1 billion years, that they were once part of a supercontinent, rising during an ancient orogeny before being worn down by erosion and later uplifted again. Another proposes that they are remnants of a rift system, formed when tectonic plates began to pull apart and then, paradoxically, froze in place. But none of these models fully explain the Gamburtsev's height or their preservation. Even more puzzling is the fact that these buried peaks may have played a central role in Antarctica's transformation into the icy continent we know today. Scientists now believe that the Gamburtsev Mountains may have been the cradle of Antarctica's vast ice sheet, that their high elevation and complex topography created the initial conditions for snow and ice to accumulate, eventually growing into the glacial mass that would spread across the entire continent. In this view, the mountains are not just a curiosity. They are the quiet architects of a planetary shift. But how do mountains hidden for millions of years shape climate and history on a global scale? Could their valleys hold sediments that contain a climate record going back to before the first ice? Could there be lakes in the basins between their peaks, sealed under pressure, like Lake Vostok, harboring ancient life or unknown geochemical processes? Or is it possible that beneath the deepest ice, preserved in some untouched cavern, there lies an ecosystem, or a history we haven't yet imagined? Some researchers have speculated about geothermal anomalies beneath the range, unexplained heat signatures that may hint at underlying volcanic or tectonic activity, perhaps even hidden pockets of warmth that have altered the formation of the ice above. Others note the symmetry of the range, its sharp contours, its seemingly youthful features, which should not exist in such an ancient, geologically stable region. Could there be more beneath the ice than stone, more than erosion and uplift? Fringe theorists, as always, propose bolder ideas, some imagining buried ruins, lost technologies, or the remnants of an antediluvian civilization encased in glacial time. While there is no evidence to support such claims, the sheer inaccessibility of the Gamburtsev Mountains makes them fertile ground for speculation. For now, they remain unvisited, unreachable by traditional means, mapped only by echo and inference. And that, perhaps, is what gives them their power. Unlike other ranges that dominate the horizon, the Gamburtsevs are invisible. We know them only through their reflection in instruments, through gravitational fluctuations, radar pulses, and the faint trembling signals of seismic waves. They are real, yet ghostly, solid, yet unreachable. What secrets might be locked in their rocks? What relics of Earth's earliest life, earliest water, earliest shifts? In a world mapped down to the millimeter by satellites and drones, the idea of an entire mountain range, larger than the Alps, still hidden beneath ice, evokes something rare: wonder, awe, and perhaps a quiet reminder of how much we still don't know. The Gamburtsev Mountains remain out of reach, buried beneath 4 kilometers of silent, frozen time. But their peaks, lost beneath the weight of the world, still cast a shadow over the edge of our understanding. And one can't help but wonder, what else lies beneath the ice, waiting to rise in the data like mountains from the deep? Beneath the unbroken silence of the East Antarctic ice sheet, where buried mountain ranges sleep in total darkness, another shadow lingers, less geological, more historical. A human story, wrapped in secrecy and speculation, tied not to tectonic shifts or ancient forests, but to war, ideology, and one of the most secretive regimes of the 20th century. This is the story of the lost Nazi expeditions to Antarctica. In early 1939, just months before the outbreak of World War II, a specially outfitted German vessel set sail from Hamburg under the orders of the Third Reich. Its destination, Queen Maud Land, a remote, icebound sector of Antarctica claimed at the time by Norway. The ship was the Schwabenland. On board, planes, scientists, and a carefully selected team from the German Navy and Luftwaffe. The expedition was no mere adventure. It was planned with precision, equipped with long-range aircraft fitted for icy terrain. Over the course of several weeks, the German team dropped thousands of metal darts, each bearing a swastika insignia, across a wide swath of land, effectively marking territory. They named the region Neuschwabenland, New Swabia. Official records state that the expedition was scientific in nature, focused on mapping, meteorological research, and securing potential whaling grounds to aid the German war economy. And in many ways, that explanation holds. The mission returned with aerial photographs, ice core data, and climate observations. Nothing outwardly unusual, nothing sinister. And yet, it was never repeated. Why send a military-backed operation to a distant, frozen wasteland on the eve of global war? Why claim land that would offer no strategic value in a conventional sense? And more curiously, why do rumors persist to this day that something more happened there? Something that was never entered into the official record? In the decades that followed the fall of Nazi Germany, whispers grew. Claims circulated of secret Antarctic bases, of bunkers built deep into the rock, hidden beneath the ice. Allegations emerged of German U-boats fleeing south in the final days of the war, carrying high-ranking officials and classified technologies to safety beyond the reach of Allied forces. Some pointed to the U-977 and U-530, two German submarines that surrendered months after the war's end, mysteriously late and without clear explanations for their whereabouts during that time. Could they have been part of a final escape? A retreat to a last redoubt? By the late 1940s, the United States launched a large-scale military operation to Antarctica, Operation High Jump, led by Admiral Richard E. Byrd. Officially, the mission was described as a training and research exercise meant to establish an American presence in the region. But the scale of the deployment was remarkable. 13 ships, 33 aircraft, and over 4,700 personnel. Some observers wondered, why such force? What did the United States expect to find or confront? Admiral Byrd himself gave cryptic remarks in a post-mission interview, warning that the United States must prepare to defend against aircraft flying from pole to pole at incredible speeds. His comments, vague and alarming, have been interpreted in many ways. Some dismiss them as mistranslation, others as misdirection. But the questions remain. What was the true purpose of Nazi Germany's Antarctic expedition? Was it really just about scientific research, or was something more covert underway? And if a base was ever established, what could have been its purpose? Research, refuge, or something more arcane? Some theories, far outside the mainstream, imagine a continuation of Nazi occult interests. Legends of hidden technologies, anti-gravity craft, and strange energy sources surface repeatedly in fringe literature. These ideas are typically dismissed by historians, but their persistence is notable. Fueled by a lack of transparency, incomplete archives, and the Cold War's culture of secrecy, they have become woven into a kind of modern mythology. There are claims, unverified and unverifiable, of vast caverns beneath the ice, warm from geothermal heat, capable of housing entire facilities, of recovered technologies spirited away in the aftermath of the war, even of sightings, strange lights, aircraft, and objects moving beneath the surface radar. More measured investigations have explored the geology of Queen Maud Land and found plausible locations where caves and ice-free pockets could exist. Beneath the glacier, heat from the Earth's interior creates isolated zones of liquid water and potentially habitable space. Could these have once been used, or at least explored, by early expeditions? If so, why the silence? To this day, the fate of certain wartime records remains unknown. Parts of the Nazi archives were destroyed. Others were seized by Allied intelligence agencies and locked behind classified designations. Among them may lie the complete account of Neuschwabenland. Or perhaps it was never more than it seemed, a brief, strange detour of a regime hungry for scientific glory. But the mystery endures, because so little has been confirmed, and so much remains out of reach. Queen Maud Land remains remote, hostile, and largely inaccessible. No known structure has ever been discovered. No definitive proof has surfaced of underground facilities or surviving technology. And yet, every now and then, in the white silence of Antarctica, new anomalies emerge. Magnetic readings, thermal signatures, unexplained formations buried beneath the ice. Coincidence? Or clues? Was Antarctica merely the stage for wartime ambition, or a deeper chapter in a story still unfolding? The questions remain, echoing in the frost just beyond the edge of certainty. As we leave behind the icy legends of secret bunkers and vanished expeditions, we return once more to what lies deep beneath the Antarctic surface. Not artifacts of war or ancient maps, but something far older and perhaps more volatile. Beneath the crushing silence of the ice sheet, in isolated pockets buried miles below the surface, something stirs in the dark. Not movement, not sound, but pressure, chemical potential, a slow, invisible force sealed within the frozen crust for millions of years. These are Antarctica's subglacial methane reservoirs, hidden vaults of gas trapped beneath the ice, preserved in ancient sediments that have not seen sunlight since long before humanity emerged. The discovery of these reservoirs has only come in recent decades, as ground-penetrating radar, seismic readings, and satellite-based observations have revealed startling anomalies beneath the continent's frozen shell. In the low-lying sediment basins beneath West Antarctica, particularly beneath the Wilkes and Mercer ice streams, scientists have found extensive deposits of organic-rich material, former seafloors and floodplains buried by shifting ice and time. Within this organic matter, under immense pressure and aided by geothermal warmth, methane has formed. Methane, an invisible, odorless gas, simple in its molecular structure, yet immensely potent in its effects. Trapped beneath hundreds of meters of ice, it waits. But for how long? In the right conditions, methane can remain locked in place for millennia. It can bond with water to form clathrates, crystalline cages of ice that imprison gas in a frozen lattice. These structures are stable only under specific pressures and temperatures, but Antarctica is not entirely static. Beneath the ice sheet, geothermal heat rises from the Earth's core. Subglacial lakes shift and drain. Ice streams flow, slowly but unstoppably, toward the coast. And as global temperatures rise, the surface above begins to melt, not just at the edges, but from within. Could these changes disturb the ancient equilibrium? What happens if the ice thins, the pressure drops, or the temperature rises, just enough to tip the balance? Could massive plumes of methane suddenly be released, as they have been in Siberia and the Arctic Ocean? The implications are sobering. Methane is a greenhouse gas over 25 times more effective than carbon dioxide at trapping heat in the atmosphere. A sudden release from Antarctic reservoirs, on the scale of gigatons, could exacerbate climate change dramatically. It would not just be an environmental shift, but a feedback loop, one capable of accelerating ice melt, sea level rise, and planetary warming in unpredictable ways. But the mystery doesn't stop at climate science. There's another layer to this buried system, one less understood and far more intriguing. Within the sediment cores drilled from beneath the West Antarctic ice sheet, researchers have found more than just gas. They've discovered ancient microbial life, organisms that survive in oxygen-starved, high-pressure, methane-rich environments. These microbes feed off the carbon trapped in the ice and sediment, producing methane in the process. Could some of the methane reservoirs we detect today be alive? Not just static pockets of gas, but dynamic, self-sustaining ecosystems sealed away beneath the ice for millions of years. The idea is no longer theoretical. In isolated subglacial lakes like Lake Wilkes and Lake Mercer, scientists have detected living microbial communities thriving in total darkness. They metabolize carbon and sulfur, adapt to extreme salinity, and exist under hundreds of meters of ice without sunlight or oxygen. These life forms may represent some of the most resilient organisms on Earth, models for survival on other planets or moons. Could similar life exist in the methane-bearing sediments beneath Antarctica's ice? And if so, what kind of life is it? Ancient strains from Earth's deep past? Or something that evolved in total isolation, cut off from every other branch of the biosphere? The deeper the drills go, the more strange the world becomes. Some have begun to speculate about the broader significance of these discoveries. If methane is being actively produced by life forms deep beneath the Antarctic ice, could that explain some of the unexpected gas signatures detected in other parts of the continent? Could there be methane seeps, slow and steady, contributing to unexplained atmospheric patterns? Could it even connect to the more anomalous radar readings, temperature fluxes, or magnetic anomalies detected in nearby regions? And, taking the questions further, are we simply uncovering the remnants of Earth's ancient cycles, or disturbing a delicate balance we barely understand? Fringe theories have also entered the conversation. Some suggest that under certain conditions, these methane reservoirs, combined with geothermal vents, liquid water, and trapped oxygen, could form the foundation for complex ecosystems. The idea of hidden biospheres, of warmth and energy beneath the frozen wasteland, has become a source of fascination not only for scientists, but for writers, thinkers, and those who watch the edges of conventional knowledge. Is it possible that life beneath Antarctica never ceased, but simply adapted, burrowed down, and waited? Could there be an entire layer of the planet's evolutionary story unfolding beneath the ice, hidden from us not by distance, but by depth? For now, the methane stays locked away, sealed beneath layers of ice and time. But the balance is fragile, and in a world of changing temperatures and shifting climates, the pressure is rising. What else sleeps in the dark? What else waits to be released? Chemical, biological, or something stranger still? In Antarctica, even the silence breathes. From the pressurized silence of methane-filled sediments to the microbial breath of life sealed beneath ancient ice, Antarctica continues to reveal secrets far older than our written history. But there is one question, larger, more haunting, that refuses to melt away, even in the face of scientific skepticism. A question that has echoed for decades through whispered theories and cryptic clues. Could there once have been an ancient civilization beneath the Antarctic ice? It's an idea that stretches the imagination, and yet the landscape invites the question. Picture it, a continent larger than Europe, buried in a sheath of ice over 2 kilometers thick. Beneath that frozen layer lies a continent not of lifeless rock, but of mountains, valleys, river basins, and lost shorelines. Features once exposed to open sky, rain, and forest. Geological studies confirm it. Antarctica was not always frozen. Tens of millions of years ago, it supported vast forests, wetlands, and temperate climates. Even as recently as 6,000 years ago, according to some controversial climate models, parts of its coast may have been free of ice. And yet, there are no ruins, no temples, no tools, no signs of agriculture, no names carved in stone. Still, questions persist. Some of the earliest stirrings of this mystery can be traced to the 16th century Piri Reis map, whose enigmatic southern coastline has long been interpreted by some as a depiction of ice-free Antarctica. While mainstream scholars view the map as a collage of earlier charts, with distortions common to the cartography of the time, others see in it the outline of a landmass that should not have been known. Could it reflect a distant memory, passed through ancient seafarers long before the modern age? More recently, satellite imagery has added to the puzzle. High-resolution scans have revealed anomalies beneath the ice, linear formations, geometric patterns, and symmetrical shapes that seem, to the eye, oddly regular. Among the most discussed is a structure near the Shackleton Range, an arrangement of ridges and depressions that, from above, bears a resemblance to the layout of a city grid. Another is a dome-like shape protruding from the ice, with concentric circles that echo Plato's description of Atlantis. Skeptics argue that these features are natural, glacial formations, nunataks, and rock exposures shaped by millennia of pressure and flow. And in many cases, that may be true. But the question remains, can we truly rule out the possibility of something more? Some fringe theorists have gone further, drawing on myths of lost civilizations, Atlantis, Lemuria, Mu, and aligning their locations with the changing poles of Earth's axis. According to the controversial Earth crust displacement theory, proposed in the mid-20th century, the entire crust of the Earth may have shifted suddenly in the ancient past, displacing Antarctica from a more temperate zone to its current polar position. If that were true, and if human or pre-human civilizations existed during that time, then much of their history could now lie entombed under ice, inaccessible and forgotten. There is, of course, no concrete archaeological evidence to support this, but in 2017, seismic and ground-penetrating radar studies detected a series of subglacial features in East Antarctica that further fueled speculation. Among them, anomalous heat signatures, localized magnetic fluctuations, and unusual topographic formations buried far below the surface. Could these be ancient structures, remnants of walls or foundations, or are they simply the result of geothermal activity, tectonic stress, or long-buried geological upheaval? Scientists are cautious. The Antarctic Treaty prohibits large-scale excavation, and the sheer difficulty of drilling through miles of ice makes direct investigation almost impossible. The answers, if they exist, are out of reach, for now. Still, the human mind is drawn to patterns, to possibilities, to mysteries that feel just out of focus. We know so little about the earliest chapters of our species, the rise and fall of cultures now lost to sand, forest, and ocean. Entire cities have vanished under volcanic ash, jungle vines, and rising seas. Why not under ice? Could it be that beneath the Antarctic plateau lies not just frozen rock, but forgotten memory? Some believe that if we are ever able to drill deeper, scan clearer, or interpret the landscape more fully, we might find not the fantastical ruins of science fiction, but subtle traces: a carved stone, a buried hearth, a tool, something small, unassuming, yet undeniable, a fragment of a story we were never taught to tell. Until then, Antarctica remains the most inaccessible of archives. A continent of ice, yes, but also of silence. One that guards its history with the weight of time itself. And so we're left with this lingering thought. If a civilization did once thrive here, before the ice came, before memory froze into myth, how would we ever know? And more curiously, if something lies beneath, do we dare uncover it? In a world where so much has been mapped, measured, and explained, Antarctica continues to whisper back the only answer it has ever offered. Wait, watch, wonder. From speculations of long-lost civilizations beneath the ice, we return once more to the quiet, living heart of Antarctica, far beneath its surface, where sunlight cannot reach and time seems to stand still. But here, in this dark, pressurized world, something moves, something microscopic, ancient, and very much alive. Scattered beneath Antarctica's vast ice sheet are more than 400 known subglacial lakes, bodies of water sealed under kilometers of ice, cut off from the atmosphere for millions of years. These lakes are held in a delicate equilibrium, crushed by pressure, warmed by geothermal heat, and insulated by the ice above. In their silence, they offer something extraordinary: a look into the deep past, into Earth's forgotten biology. Among them, Lake Wilkes and Lake Mercer, located beneath the West Antarctic ice sheet, have become the focus of intense scientific exploration. In recent years, teams from the Wilkes Ice Stream Subglacial Access Research Drilling Project, known as WISARD, successfully drilled into these lakes, retrieving water samples never before touched by the outside world. What they found inside challenged every assumption. Despite the extreme conditions, no light, sub-zero temperatures, crushing pressure, and total isolation, life exists. The samples revealed thriving microbial ecosystems, composed of bacteria that survive by breaking down minerals in the surrounding sediments and feeding on iron, sulfur, and methane. These microorganisms do not depend on photosynthesis, as surface life does. Instead, they rely on chemosynthesis, extracting energy from the very rocks and chemical reactions around them. It's a survival strategy more commonly associated with life at the deepest ocean vents than under polar ice. But here, in these hidden lakes, life has not only endured, it has adapted. Some of the DNA sequences recovered show little resemblance to anything known. They hint at lineages that diverged long ago, perhaps before the last ice age, perhaps before the formation of Antarctica as we know it. Could these microbes be survivors from a time when the continent was still warm and forested? Organisms that retreated into the depths as the ice closed in, holding out through epochs of cold in secret, sunless waters. And if so, what might they still carry within them? What knowledge? What chemistry? What history? The implications reach far beyond Antarctica. These life forms have become models for what might exist on other worlds, on the icy moons of Jupiter and Saturn, where oceans lie beneath crusts of ice, just as they do here. Europa, Enceladus. If life can thrive in the sealed lakes of Antarctica, might it not do the same in the subsurface seas of other planets? NASA and other space agencies have taken note. The drilling techniques used in Antarctica now inform the planning of future missions, where robotic probes might one day drill through extraterrestrial ice in search of alien microbes. In this way, Antarctica becomes a training ground not just for science on Earth, but for the search for life beyond it. But back on this planet, the mysteries still deepen. Not all subglacial lakes are the same. Some, like Lake Vostok, one of the largest and deepest, remain largely unexplored. Sealed for at least 15 million years, Vostok's waters may host entirely unique biospheres, shaped by pressures and chemistries unknown elsewhere on Earth. In preliminary analyses of samples taken near the lake, scientists found traces of DNA that could not be easily classified. While contamination is always a concern, the possibility of undiscovered life remains tantalizing, and it leads to deeper questions. If life can persist, cut off from the surface for millions of years, what else might be preserved in these waters? Could microorganisms hold ancient genetic memories, snapshots of Earth's biosphere before the rise of mammals? Could they represent alternate evolutionary paths shaped by isolation and adaptation? Or even microbial fossils, long dead, that record biochemistry from vanished eras? In the most speculative corners of thought, some wonder if these lakes could contain more than microbes. If the complex ecosystems hinted at by some sediment samples, rich in organic compounds, might include more elaborate organisms, nematodes, extremophilic fungi, even multicellular life evolved in absolute darkness. No evidence yet confirms this, but no expedition has ever penetrated deep enough or long enough to say for sure. And so, we are left with a simple, staggering truth, that in the coldest, most remote place on Earth, life may be thriving in silence. Unaffected by the sun, unaware of the surface, evolving in a realm so alien that it feels more like science fiction than planetary science. How many more of these lakes lie waiting, undetected beneath the ice? How many forms of life have yet to be catalogued, isolated, or awakened? Could unlocking their secrets teach us not just about biology, but about time, resilience, and the boundaries of existence? Or might we learn something far more unexpected? In Antarctica, even the smallest organism can carry the weight of mystery. Even the simplest cell can hold an ancient truth. And as long as the ice holds, so too will the questions, untouched, unresolved, and quietly alive beneath our feet. From the microcosmic resilience of ancient life forms thriving in subglacial lakes, We turn now to a different kind of mystery, one not biological, but geological. A force that pulses beneath the ice, silent and invisible, yet capable of reshaping the very foundations of the frozen continent above. Welcome to Marie Byrd Land. Remote, windswept, and hauntingly vast, Marie Byrd Land is one of the most isolated regions in all of Antarctica. Situated in West Antarctica between the Ross Sea and the Amundsen Sea, it spans more than 1.5 million square kilometers and remains one of the few landmasses on Earth without any permanent human presence. Even among the desolate reaches of Antarctica, Marie Byrd Land feels especially untouched, its barren expanses watched only by satellites and passing storms. But beneath this lonely stretch of ice, something strange is happening. In recent decades, scientists conducting radar and seismic surveys across West Antarctica began detecting an anomaly deep beneath the surface. Hidden below Marie Byrd Land lies a region of unexpected warmth, an anomalous heat source that seems to rise from the Earth's crust, directly beneath the ice sheet. It's not a subtle phenomenon. This subterranean heat is melting the base of the ice sheet, creating massive subglacial lakes and lubricating the ice above, causing it to flow more rapidly toward the ocean. The presence of geothermal heat beneath Antarctica is not in itself surprising. The continent, after all, is home to known volcanoes, some of them still active, and a number of geothermal hotspots. But the heat source beneath Marie Byrd Land is unusual in its intensity and scale. Satellite measurements of ice elevation and gravitational fields suggest that a large plume of heat, possibly a mantle plume, is concentrated in this region, stretching up from deep within the Earth's interior. And yet, the data doesn't quite add up. The plume appears to be relatively young in geological terms, perhaps tens of millions of years old, yet it underlies ice that has been stable for far longer. Some scientists suggest that this mantle heat may be a key factor in why the West Antarctic ice sheet is far less stable than its eastern counterpart. But others ask a different question. Why here? And why now? What makes Marie Byrd Land the focal point of such a powerful, concentrated heat source? Is it a natural byproduct of mantle convection? A lingering scar of past tectonic collisions? Or is it something else entirely, something we have yet to fully understand? Adding to the intrigue is the curious positioning of Marie Byrd Land within what's known as the West Antarctic Rift System, a vast, partially submerged tectonic boundary that has stretched and thinned the crust of this region over millions of years. Some researchers believe that the anomalous heat is rising through these faulted zones, where the Earth's interior is unusually close to the surface. Others speculate more boldly. The heat plume's shape and behavior bear certain resemblances to volcanic hotspots found in places like Yellowstone and Iceland, regions where magma wells up from deep within the planet, sometimes with dramatic, even catastrophic, consequences. Could Marie Byrd Land be hiding a similar feature? A massive, slow-burning supervolcano buried under kilometers of ice. There is no eruption crater, no definitive sign of a volcanic caldera. But satellite observations have detected areas of ice surface uplift, subtle bulges that suggest something beneath is expanding, heating, pushing upward. And then there are the stranger questions. Why does the magnetic field in this area fluctuate more than expected? What accounts for the subtle but persistent gravitational anomalies that have been detected from orbit? Could there be massive voids, caverns, or even hollowed-out chambers beneath the surface, formed by geothermal activity or by something else? To some, these questions echo more fringe theories, ideas of artificial heat sources, hidden bases, or even ancient machinery buried beneath the ice. Such notions are not supported by mainstream science, yet they persist in the public imagination, fueled by the remoteness of the location, the strangeness of the data, and the long history of secrets associated with Antarctica. What is known, however, is this. The anomalous heat source beneath Byrd land is reshaping the landscape above it. It is accelerating ice flow, creating meltwater lakes, destabilizing the West Antarctic ice sheet in subtle but significant ways. And it may be accelerating a much larger process, one with global implications. As the ice thins and flows more rapidly toward the sea levels rise. Coastal cities around the world are affected. Entire ecosystems shift. And the mystery that begins with warmth in the frozen south reaches outward, connecting continents and futures. But the deeper cause, the true nature of the heat source, remains unresolved. Is this the start of a long-sleeping geological force slowly awakening? Or is it simply one more piece of Earth's complex and ever-changing puzzle, misunderstood only because we have not yet seen the full picture? In the end, Byrd land keeps its silence. There are no expedition bases here, no lights, no roads, only ice, and something beneath it. And as the warm breath of the Earth rises up from the dark, melting the underside of Antarctica's ancient crown, one cannot help but wonder, what else stirs in the depths, unseen, unknown, and still waiting to be named? As we leave the strange warmth rising from beneath Byrd land, we surface once more into the cold, but not to the blinding white void that defines so much of Antarctica. Instead, we arrive at a place where the ice disappears entirely. A place that should not exist in a land of snow and glaciers. This is the McMurdo Dry Valleys. Tucked between massive mountain ranges near the Ross Sea coast, the dry valleys stretch across a vast expanse of rocky desert, an Antarctic paradox. Here, the ice retreats and wind-swept plains lie bare, scorched not by sun, but by the constant scouring of katabatic winds, bone-dry gales that scream down from the polar plateau at speeds of over 300 kilometers per hour, evaporating any trace of moisture in their path. The result is otherworldly. Jagged hills of exposed stone rise above gravel plains where not a drop of rain has fallen in nearly 2 million years. The air is so dry that the lakes, fed by distant glacial melt, form thick, icy crusts beneath which hypersaline water persists in quiet defiance of the climate. The landscape feels lifeless, lunar, and ancient. And yet, something strange survives here. Despite the absence of liquid water, plant life, or any visible sign of a sustaining ecosystem, life endures in the dry valleys. In the soil, beneath the surface, and even within the ice of frozen lakes, extremophile organisms, tiny, resilient microbes, have adapted to this brutal environment in ways science is still struggling to understand. Some survive by clinging to minerals, drawing sustenance from chemical reactions in the rock itself. Others live within the ice layers, photosynthesizing through thin veins of meltwater in summer's brief light. These life forms function at the edge of possibility, stretching our definitions of what habitable means. If such life can thrive here, in the most extreme environment on Earth, what might that say about other barren worlds? NASA and other space agencies often use the dry valleys as an analog for Mars. The similarities are striking: dry, cold, wind-blasted, and seemingly inert, yet still capable of harboring life. It is one of the best terrestrial test beds for planetary exploration. Rovers and sampling technologies destined for Mars are tested here, among the rocks and permafrost. But there is something else about the dry valleys, something harder to define. They feel untouched, silent in a way that's deeper than quiet, eerily so. The land carries the stillness of deep time, like a place that has paused between moments for far longer than it should. Explorers and researchers who have walked these valleys often describe a sense of being watched, not by any presence, but by the weight of the place itself, as though the stones remember something we do not. And then there are the anomalies. Some geological formations within the dry valleys remain difficult to explain. Polygonal patterned ground, strange geometric tessellations etched into the soil, have formed without frost cycles, seemingly in defiance of local climatic conditions. Boulders have been found perched in perfect balance, with no evidence of how they arrived at such improbable locations. And in certain parts of the valley, magnetic readings have fluctuated unexpectedly, suggesting localized irregularities in the Earth's crust. One of the most well-known mysteries of the region is Blood Falls, an iron-rich, rust-colored stream that seeps out of the Taylor Glacier and spills into the valley floor. The source of the red liquid lies deep beneath the ice, in a pressurized subglacial reservoir, where microbial life metabolizes iron in oxygen-deprived darkness. How this isolated ecosystem has survived for so long, and why it emerges so vividly into this desolate place, remains a subject of ongoing research and speculation. Some have wondered, is there more than just strange chemistry here? Could these valleys, with their strange alignments, hidden life, and peculiar stillness, hold remnants of something older? Something not just natural, but intelligent? No evidence suggests that human or pre-human civilizations ever settled Antarctica, and yet the geometry of the land invites the question. The symmetry, the stark isolation, the suggestion of purpose behind the shapes carved by wind and time. Even in mainstream circles, the dry valleys are seen as time capsules, windows into what the Earth once was, or might one day become. A preview of a dying planet, or the remnants of a world before ours. And so, the dry valleys remain one of Antarctica's most studied and least understood features. Every rock, every salt-crusted lakebed, every whisper of wind that passes through its canyons seems to carry a message written in a language we've only begun to hear. What was this land before the cold came? What else might sleep beneath the cracked surface, waiting for a thaw that may never come? And perhaps more unsettlingly, are we alone in the silence, or are we simply too new, too temporary, to understand the memory of the stones? In the end, the dry valleys ask not for answers, but for questions. And in Antarctica, that is where all discovery begins. From the ghostly silence of the dry valleys, where nothing grows yet something lingers, we descend now into the hidden arteries of the continent, into places not merely below the ice, but within it, into corridors of frozen light, into vast, glowing chambers that few have seen, and even fewer have truly understood. Welcome to Antarctica's blue ice caverns. Tucked beneath glaciers and ice shelves, stretching beneath the Ross ice shelf, and deep within the coastal walls of the continent, these caverns are not visible from the air. They are discovered, mostly by accident, by satellite thermal imaging, radar anomalies, or during hazardous field expeditions probing cracks in the glacial surface. When researchers do find them and venture inside, what they witness is unlike anything else on Earth. The air turns still. The temperature drops. The walls shimmer. Everything is bathed in an eerie, otherworldly glow, the product of pure, compressed ice, absorbing red light and scattering only the deepest, most spectral blue. The deeper you go, the more the ice becomes like crystal, transparent, prismatic, alive with color. Some of these caverns stretch hundreds of meters across. Arched ceilings rise like cathedral domes, carved not by human hands, but by geothermal vents, subglacial rivers, and slow, unseen melt cycles. In some places, shafts of light shine in through cracks above, painting the walls with a hue so deep and saturated it feels unreal, like walking through frozen moonlight. But the beauty masks a deeper mystery. Why do some of these ice caverns form in seemingly random places, far from known heat sources? Why do they maintain their structure while the surrounding ice flows and shifts over time? And how are some of them so large, so structurally stable, in a landscape otherwise defined by movement and collapse? One of the most striking examples lies beneath Mount Erebus, Antarctica's most active volcano. Here, ice caves form from geothermal heat rising through the mountain's flanks. The walls are thick with hoarfrost and crystalline formations that glisten like glass, and the interior remains surprisingly warm, around freezing even in the coldest months. Sensors placed in these caverns have picked up strange gas mixtures, including elevated levels of methane and carbon dioxide, as well as small fluctuations in magnetic activity. Some of this is explained by volcanic activity, but not all. Other caves, such as those found under the Ross Ice Shelf or near the edge of the Transantarctic Mountains, do not align with volcanic systems. In these regions, caverns appear without obvious geothermal origins, and some connect to unexplored subglacial lakes, creating complex networks of frozen passageways. The walls are sometimes unnaturally smooth. In rare cases, explorers have reported symmetrical formations, repeating patterns that seem carved, not melted. Are these simply the result of steady glacial erosion? Subsurface meltwater sculpting the ice over time? Or could they point to a more complex, perhaps episodic process, one involving deeper flows of geothermal energy, or even long-lost atmospheric conditions that left behind structural relics in the ice? No one knows for certain. Some scientists speculate that ancient methane bursts or episodic geothermal surges from deep within the crust may have helped shape these caverns. Others suggest that some of the caves may act as pressure valves, natural release points for subglacial tension, where gases accumulate and periodically escape. These processes, if understood more fully, could help explain everything from ice sheet movement to atmospheric anomalies above the poles. And then, of course, there are the more speculative theories. Over the years, rumors have emerged of vast caverns large enough to house aircraft, equipment, or even exploratory outposts, spaces so deep and so sheltered that they maintain a constant temperature and remain hidden from satellite detection. Some fringe theorists have pointed to these caverns as possible locations for lost expeditions, hidden technologies, or even remnants of civilizations buried before the ice came. While such claims are not supported by evidence, they are not born of imagination alone. The sheer scale and obscurity of these caverns invite speculation. In places where light never reaches and ice shifts on timelines beyond human comprehension, even the rational mind begins to wonder, what else might lie hidden? Could these caves preserve ancient life, sealed in ice since before the last interglacial period? Could they store atmospheric records or mineral traces untouched by erosion or exposure? Or perhaps, most compellingly, could they connect, linking lakes, vents, and deeper geological features into a kind of subterranean web beneath the continent? We know that Antarctica holds hundreds of subglacial lakes connected by rivers that flow in darkness. We know that methane accumulates beneath the ice, that ancient microbes endure where nothing should live, that seismic readings hint at hollow spaces, still unexplored. Might these glowing caverns be more than isolated features? Might they be the threshold to something larger? As researchers continue to map the ice sheet with radar and satellite technology, new anomalies emerge, pockets of unexpected warmth, voids beneath the surface, even subtle shifts in magnetic signatures. But field access is limited, drilling is costly, and the risks of collapsing caverns or sudden gas release are too great for most expeditions to justify. So for now, these cathedrals of blue light remain mostly undisturbed, their walls whispering with the echoes of melting centuries, their depths holding silence like a secret, and in a continent shaped by extremes, by absence, by stillness, by time stretched thin and cold. These glowing hollows may be some of the last places left where the unknown still glows, waiting patiently in the dark. What forces shaped them? What histories lie frozen within? And if we dared to go deeper, what might we find glowing in the ice beneath a silence millions of years deep? From the blue glowing caverns deep within the ice, we now emerge into the blinding brightness of the Antarctic surface, into a vast, alien white landscape where nothing seems to move, and time itself feels held in suspension. But here, scattered across the ice like messages from the cosmos, lies one of the continent's most unexpected treasures: meteorites. In the world of planetary science, there is no place on Earth quite like Antarctica for finding rocks that have fallen from space. Each year, as the Antarctic winds scour the surface and the ice shifts slowly across the continent, dark stones emerge, small, silent, and out of place. In a land made almost entirely of white and blue, a black rock stands out like a beacon. Some of these meteorites are no larger than a fist, others weigh several kilograms, but all of them share one strange story. They arrived here from beyond our world. What makes Antarctica so ideal for collecting meteorites isn't just the contrast in color, it's the way the ice preserves them. Unlike other parts of the planet, where wind, water, and soil quickly erode or bury space rocks, the Antarctic cold keeps them intact. The dryness prevents rust. The ice carries them slowly toward mountain ranges known as stranding zones, and the surface winds eventually expose them, allowing researchers to simply walk across the ice, searching for the foreign among the familiar. Since organized searches began in the 1970s, more than 60,000 meteorites have been recovered from the continent. Many are fragments of asteroids, broken apart long ago in the asteroid belt. Some have been traced to the Moon, a rare few to Mars. But it is not just their origin that captivates scientists, it's what they might still contain. Meteorites are time capsules. Locked within them are minerals, isotopes, and even gases that predate Earth itself. They carry the fingerprints of the early solar system, frozen in place for billions of years. Some contain the building blocks of life, organic compounds like amino acids, carbon chains, even water-bearing minerals, formed in the cold of interstellar space and delivered to our planet through cosmic collision. Could these fragments have once seeded Earth with the raw ingredients for life? That question has haunted astrobiologists for decades, and in Antarctica, it finds fertile ground. In 1984, a small black rock was discovered in the Allen Hills region of Antarctica. Catalogued as ALH 84001, it would eventually become one of the most controversial meteorites ever studied. After detailed analysis, NASA scientists in the 1990s announced that the meteorite, originating from Mars, contained possible microfossils, tiny, worm-like structures buried within the rock, along with mineral patterns and organic molecules that hinted at biological processes. Was this evidence of ancient Martian life? The scientific community erupted into debate. Many argued that the structures could have formed through purely geological processes, that the organic compounds might be contamination or abiotic in origin. But the idea had already taken root, that a rock found in Antarctica might carry within it the remnants of life from another world. It remains unresolved. And ALH 84001 is not alone. Other Antarctic meteorites have revealed strange isotopic ratios, unusual crystalline structures, and patterns of chemical weathering that suggest long, slow journeys through space and unknown interactions before they arrived here. Some researchers have pointed to the fact that certain meteorites contain nanodiamonds, formed under pressures not found on Earth or in standard meteorite collisions. Others have noted inclusions of hydrogen isotopes that may trace back to interstellar clouds, suggesting that at least part of the material in these rocks predates our solar system entirely. What are we really holding when we lift one of these ancient fragments from the ice? A splinter of a shattered planet? A survivor of a cosmic explosion? A messenger from somewhere far beyond the reach of any spacecraft? And yet, there are mysteries closer to Earth as well. In 2022, a team of researchers uncovered one of the largest meteorites ever found in Antarctica, a 17-pound specimen buried just beneath the surface. Its composition, age, and trajectory are still being analyzed, but its discovery raises familiar, haunting questions. How many more lie buried beneath the ice? How many ancient fragments of Mars, the Moon, or something stranger still, are waiting, preserved in silence, awaiting the day they are uncovered? The extreme cold and remoteness of the continent have made systematic exploration difficult. Many regions remain unsearched, and the possibility remains that larger, older, or more complex meteorites have yet to be found. Some may lie beneath glaciers, slowly migrating over millennia. Others may rest near known heat anomalies, where ice has thinned and ancient materials may be exposed. And then there is the deeper, more speculative idea. If meteorites can bring life-bearing molecules to Earth, could they have brought something more? Could some fragments, rare, ancient, and as yet unrecognized, carry not just chemical blueprints, but something more structured? A kind of code? A signature? A signal? There is no proof of such a thing, and yet the allure remains. In Antarctica, beneath the indifferent sky, meteorites lie in wait, cold, ancient, and silent. Each one a mystery, each one a story older than Earth itself. And as long as we keep looking, the ice may still surprise us, offering pieces of the cosmos hidden in plain sight beneath a land of snow and silence. From the black stones of space scattered across the Antarctic ice, we turn now to something born not in the stars, but in the seas. Something ancient, immense, and almost unbelievable. Not a meteorite, but a fossil. Not from another world, but from an older Earth. Buried in rock, not ice. Hidden beneath layers of time rather than snow. In Antarctica, paleontologists have unearthed the bones of giants, of prehistoric creatures that once ruled the southern seas. And among the strangest, most captivating of these are the fossils of giant penguins. Here, in a land now inhospitable to nearly all life, scientists have found the remains of birds that defy expectations. Penguins that once stood nearly 2 meters tall, over 6 feet, and weighed more than 100 kilograms. Towering, flightless hunters that glided through ancient oceans with power and grace. Creatures that, by size alone, would dwarf their modern relatives. The most notable among them is Palaeodiptes klakowski, a species discovered on Seymour Island near the Antarctic Peninsula. Its fossils date back some 37 million years to the late Eocene epoch, a time when Antarctica was not the frozen desert it is today, but a lush, forested landscape with rich ecosystems both on land and in the surrounding seas. These prehistoric penguins lived in a very different Antarctica. The climate was mild, temperatures were warmer, and the continent was still connected by land bridges to South America and Australia. It was a place of life, of ancient whales, massive sharks, and towering seabirds that hunted in waters teeming with fish. But why did penguins grow so large? Some scientists believe their size was an evolutionary advantage. With no land predators to threaten them, and with abundant prey in the water, penguins may have grown larger to improve diving ability, conserve body heat, and dominate ecological niches. Their bones show adaptations for deep, powerful swimming, suggesting that they could dive longer and hunt more effectively than their smaller descendants. Yet, as the climate cooled and Antarctica began its long descent into ice, the giants disappeared. Fossil records show a decline in their size and diversity, replaced by smaller, more specialized species, many of which survive today. Still, the fossils they left behind tell a story that feels almost mythic. Imagine standing in the shadow of such a creature, a penguin taller than a grown man, silent and unafraid, built like a cross between a seal and a bird. What did their calls sound like? How did they behave on land? What role did they play in the food web of a long-vanished ocean? Some remains suggest that multiple species of large penguins may have coexisted, forming a diverse and complex avian community. Other fossils hint at possible evolutionary links to seabirds that no longer exist, suggesting that Antarctica may have once been a crucible for avian evolution, a forgotten frontier of flightless giants and feathered aquatic hunters. But there are deeper mysteries. Fossils of giant penguins have been found not only in Antarctica, but also in New Zealand, Peru, and even parts of Africa, regions that were once connected through the supercontinent Gondwana. This distribution raises questions about ancient migration routes and evolutionary divergence. Did these penguins spread from a common ancestor across connected continents? Or did similar species evolve independently in isolated ecosystems? More curiously, some fossilized bones appear more robust, less avian, more dense, prompting fringe theorists to speculate about lost species still unknown to science. Some claim that, beneath the ice, there may yet be preserved remains of even larger, undiscovered birds. Others point to unusual imprints in the permafrost, interpreted by some as giant webbed footprints, though no conclusive evidence supports these claims. In certain regions, where sedimentary rocks protrude from the ice near Seymour Island or on the Antarctic Peninsula, geological layers rich in fossils remain only partially explored. What other species lie entombed in these stone time capsules? What other forms of life walked, swam, or dove through these waters before the glaciers came? And in the silence of this ice-covered world, could some fossil beds remain perfectly preserved, untouched for tens of millions of years? The conditions are ideal: cold, isolated, undisturbed. Antarctica, in its frozen state, may be one of the best natural archives of prehistoric life on Earth. But much of it remains unexplored, buried beneath kilometers of snow and stone. And so, we are left with fragments: a femur here, a partial beak there. Enough to imagine, but never quite enough to see the full picture. Enough to know they lived. Enough to wonder what else they left behind. The giant penguins of Antarctica are more than just a biological curiosity. They are a reminder that this continent, so empty, so barren, was once alive with color, motion, and towering feathered hunters. That the ice is not silence, but memory. That what seems lifeless may still be telling a story, one layer at a time. How many more fossils lie waiting beneath the ice? How much of Earth's lost history is still frozen beneath our feet, quiet, ancient, and unseen? And if creatures this extraordinary once thrived here, what else might have? As we leave behind the fossilized bones of ancient penguin giants, once kings of Antarctic shores, we shift our gaze from the remnants of the visible world to the invisible forces that quietly shape it. Forces that are constant, unrelenting, and, sometimes, unexpectedly strange. Beneath the thick ice and wind-blown silence of Antarctica, something curious has been detected. Not a sound, not a light, but a subtle shift, a whisper in the planet's gravitational field. In 2002, scientists analyzing satellite data from NASA's GRACE mission, the Gravity Recovery and Climate Experiment, discovered an anomaly beneath the icy expanse of East Antarctica. In a region known as Wilkes Land, satellite instruments picked up an unexpected gravitational fluctuation, a vast, circular region where the gravitational pull was measurably weaker than the surrounding areas. To the human body, gravity feels stable, immutable. But to the finely tuned instruments orbiting above our planet, it is dynamic, changing with mass, density, and structure beneath the surface. And in this case, the GRACE data revealed something extraordinary: a gravitational anomaly more than 300 kilometers wide, stretching beneath one of the most desolate and least explored regions of the continent. What could cause such a thing? The most straightforward explanation is mass, or rather, the lack of it. A gravitational dip typically indicates a region where mass is missing, displaced, or unusually low in density. In Antarctica, where kilometers of ice conceal the geology below, such fluctuations offer rare glimpses into the unseen. Some researchers believe this anomaly marks the site of an ancient impact, perhaps from a massive asteroid that struck the Earth around 250 million years ago. The depression in the gravitational field could represent a buried crater, now hidden beneath miles of accumulated ice and sediment. If true, it would be one of the largest known impact sites on Earth, rivaling or even surpassing the Chicxulub crater associated with the extinction of the dinosaurs. And yet, no crater rim has been confirmed, no shocked quartz, no irrefutable signatures of an impact. The evidence, while compelling, remains inconclusive. Other explanations suggest geological processes, perhaps a region of the crust thinned by ancient rifting, or an unusual mantle plume beneath the surface. Antarctica's tectonic history is complex and only partially understood. Could this gravitational anomaly be a natural consequence of long-forgotten shifts in the Earth's crust, a hidden rift valley, a collapsed mountain range? And then, as always, there are the more speculative interpretations. Some fringe theorists have suggested that the anomaly's nearly circular shape and deep central depression resemble the geometry of artificial structures, buried beneath ice for millennia. They point to the anomaly's location, within the same region as the Wilkes Land magnetic anomaly, as evidence of something more. A convergence of gravitational, magnetic, and seismic irregularities. Could this indicate something man-made, or something pre-human? No evidence supports these ideas, but the mystery persists. Adding to the intrigue is the fact that multiple gravitational fluctuations have now been detected across Antarctica, not just in Wilkes Land, but in smaller, more localized pockets. These gravitational lows suggest variations in subsurface structure, some aligned with known geological formations, others with no clear explanation. Why do some regions exhibit such sharp gravitational contrasts when the ice above shows no visible disruption? Could these fluctuations be connected to buried lakes, ancient seabeds, or even reservoirs of dense rock or metal? Could they be signaling undiscovered features, massive voids, or filled chambers, hidden for millions of years beneath the unyielding ice? The GRACE and GRACE-FO missions continue to collect data, measuring not only long-term ice loss, but also these deeper, subtler features of Earth's gravitational landscape. Yet, interpretation remains challenging. Every measurement is shaped by layers of ice, crust, and mantle, each with its own density and dynamic behavior. We are, in many ways, still blind to the deeper Earth. And nowhere is that blindness more profound than in Antarctica, a continent where more is hidden than revealed, where gravity itself seems to curve around the unknown. In a world increasingly mapped, scanned, and digitized, it is rare to encounter a region that resists explanation. But Antarctica offers just that, a canvas of anomalies where even the most fundamental forces, like gravity, can behave in unexpected ways. What lies beneath these fluctuations? Are they the echoes of ancient impacts, geological scars from a time before human memory? Are they markers of deep Earth processes, still active and shifting beneath the ice? Or could they be the signatures of something else entirely, something we have not yet imagined? As we continue to measure the world with increasing precision, such questions only grow louder. The Earth still holds its secrets, and in the silence beneath Antarctica's frozen shell, gravity itself may be the first to whisper what remains unseen. From the deep, unseen tremors of gravitational anomalies beneath Wilkes land, we now shift our gaze skyward, not to the stars, but back toward Earth. To the view from far above, where Antarctica reveals patterns too vast to be seen from the ground. Strange, elegant formations etched into the ice, geometric, precise, almost unnatural. In recent years, satellite imagery over parts of East Antarctica has captured something unexpected: vast stretches of ice marked by perfectly symmetrical hexagonal patterns. Like the scales of some ancient white creature, or the crystalline veins of a frozen web, these shapes stretch across the surface in ways that defy easy explanation. At first glance, they resemble the polygonal patterns found in frozen ground across Arctic tundra, features caused by seasonal freezing and thawing. But in Antarctica, where some regions haven't thawed in millions of years, such regularity raises questions. The hexagons, some measuring tens of meters across, appear in specific zones, often near ancient ice domes or subglacial basins. From above, their outlines form a grid of frozen geometry, almost architectural in appearance. Too perfect, some say, to be random, too precise to be ignored. So, what causes these patterns? The most widely accepted theory points to a natural process called thermal contraction cracking. As temperatures drop, the surface ice contracts, forming stress fractures. Over time, these fractures intersect and evolve into polygons, with hexagons being the most stable shape for evenly distributing tension, much like the way cracks form in drying mud, or how basalt columns create hexagonal joints in cooling lava. But in Antarctica, the scale and sharpness of these hexagons seem unusual. The cold here is extreme and continuous, without the dramatic seasonal shifts found in the Arctic. In some regions where these patterns have been observed, the ice is thought to be over 1 million years old, stable, unmoving, and sealed in silence. Why then are these geometric patterns emerging now? Some researchers propose that shifting climate patterns or geothermal heat from below may be subtly altering the surface, triggering cracking in ways we don't yet fully understand. Others suggest the influence of subglacial water, rising and falling beneath the ice, might be contributing to surface tension that manifests in unexpected ways. But not all agree. A small number of observers have raised alternative possibilities, more speculative, but no less intriguing. Could these patterns be indicators of deeper structures, natural or otherwise, pushing up from below? In some regions, the hexagonal patterns align suspiciously well with localized magnetic anomalies or gravitational disturbances. Are we simply seeing the surface echo of something deeper, something hidden beneath miles of ice? Even more controversially, some point to the hexagon as a shape of significance in both natural systems and engineered design. It's a form that appears in beehives, in carbon molecules, in snowflakes, and in human architecture. Could these formations be more than geological coincidence? Could they be relics of something constructed, now buried, and reshaped by time and ice? There's no evidence to support such claims, and yet the questions remain. Because what satellite imagery shows is not chaotic, it's ordered, repeating, structured. In one sector, not far from Dome Fuji, scientists noticed hexagonal impressions spanning nearly 1 kilometer, with each cell of the pattern nearly identical in size and shape. Ground-level expeditions confirmed the pattern, but found no immediate signs of how deep it extended, or whether it was active or fossilized. Attempts to scan beneath the ice using radar have produced mixed results. In some cases, echoes suggest voids or density anomalies beneath the patterned surface. In others, the ice appears uniform, but the data is incomplete. Access to these regions is difficult, and each year, snow accumulation further obscures the patterns, preserving them in some seasons, erasing them in others. Could these formations be transient? A fragile skin on a shifting body of ice? Or could they be stable, persisting for decades, even centuries, without anyone noticing until now? And if they are natural, why here? Why so many, in such remote and specific regions? Antarctica has always been a continent of hidden shapes. Mountain ranges taller than the Alps, buried lakes sealed from light for millions of years, magnetic fields that twist and shift unpredictably. But these surface patterns, visible from orbit, yet invisible on the ground, offer a new kind of riddle, a geometry that seems at once ancient and recent, familiar and alien. As new satellites continue to pass overhead, capturing high-resolution imagery of the continent's frozen skin, more such formations are coming into focus. Some are faint, others startlingly clear. And while many may be explained through known science, a few continue to evade certainty. Do these hexagons speak only of ice and pressure? Or are they part of a deeper language written across the continent in lines and forms we have only begun to read? What lies beneath the geometry? What stories are told in the frozen shapes only satellites can see? And if these patterns are merely the beginning, what else might Antarctica be revealing, one perfect hexagon at a time? As we follow the frozen lines of hexagonal geometry traced across Antarctica's icy surface, another pattern emerges, less regular, more enigmatic. Not a shape of symmetry, but of violent disruption. Vast depressions, circular and massive, hidden deep beneath the ice. Places where the land itself appears to have been struck, hollowed, or collapsed. These are Antarctica's bizarre crater-like structures, formations that stir debate among scientists and stir the imagination of those who study them. Beneath kilometers of ice in East Antarctica, radar scans have revealed massive circular anomalies, some spanning over 300 kilometers in diameter. They are not visible to the naked eye, nor are they marked by familiar signs like mountain ridges or ice domes. Instead, they appear only in seismic echoes, gravitational maps, and subglacial topography models detected by satellites and ice-penetrating radar. Deep bowls carved into the crust, their rims faint, their centers darker in gravitational readings. One of the most studied lies beneath Wilkes land, where a dense mass anomaly aligns suspiciously well with what many believe is a buried impact structure. If it is indeed a crater, it would rival or exceed the size of the Chicxulub impact in Mexico, the event that wiped out the dinosaurs. And yet, unlike Chicxulub, this structure shows no irrefutable signs of an impact, no shocked quartz, no melt rock, no iridium layer. The ice, for all its vast memory, keeps its secrets well. So what created it? Some geologists support the impact hypothesis. They suggest that a massive asteroid, perhaps over 50 kilometers wide, struck the Earth during the Permian-Triassic era, around 250 million years ago, triggering the most devastating extinction event in the planet's history. The alignment of timing, location, and structure is compelling. Others argue that these formations may be collapsed calderas, ancient supervolcanoes that exploded and then subsided, long before the ice entombed them. Antarctica's geological past is still poorly understood, but seismic data hints at widespread volcanic activity beneath the ice sheet. Could these crater-like structures be remnants of titanic eruptions, their outlines preserved in rock, but hidden from the world above? There's also a third possibility. Some researchers believe these anomalies could be the product of isostatic rebound, a process in which land that was once pressed down by ancient ice sheets slowly rises and reshapes after the ice recedes. Could these depressions be relics of long-lost glacial basins, distorted by millions of years of tectonic and thermal motion? And then, on the outer edge of speculation, the questions turn stranger still. If these circular formations do not conform to impact or volcanic signatures, what else could have caused them? Some theorists have proposed that such shapes could be the remnants of ancient structures, artificial or engineered, buried by time and ice. Vast domes or subterranean facilities, crushed or collapsed. Proponents of this view point to the near-perfect roundness of certain depressions, the concentric ridges, the occasional hints of radial symmetry. They note the anomalies in gravity and magnetism that sometimes coincide with these sites. But without direct access, without excavation or sample retrieval, such theories remain speculative, compelling, but unconfirmed. And Antarctica does not give up its answers easily. The thickness of the ice poses an almost insurmountable challenge. In some places, the overlying ice sheet is over 4 kilometers thick. Drilling projects, even the most ambitious, rarely penetrate far enough to reach the base of such formations. Radar and satellite data offer only shadows and shapes, glimpses of something larger, hidden just out of reach. What's more, the very stability of the ice may preserve not just geological features, but secrets. Unlike other regions on Earth, where erosion, tectonics, and vegetation obscure the past, Antarctica holds it in place. If these craters are indeed impacts or collapses, they may be among the best preserved examples on the planet. If they are something else, something older or more complex, they may still be waiting, unchanged beneath the ice. Why do so many of these structures remain unnamed, unexplored? Why do some maps show anomalies, only for them to vanish in future data releases? Are we simply looking too closely, or not closely enough? As scientific equipment improves and deeper surveys continue, we may begin to see more clearly what lies beneath these enigmatic depressions. Until then, the craters remain a quiet mystery, uncharted bowls in a frozen land, their silence louder than certainty. Are we looking at scars left by cataclysm, or windows into a chapter of Earth's story that has never been told? Whatever the answer, these crater-like structures are not just questions of shape and scale. They are questions of origin, of history, of what forces have shaped not only this frozen continent, but perhaps even the fate of the world itself. And until we uncover the ice and stand at the rim of one of these vast, unseen hollows, the question will remain suspended in the cold. What happened here? And what else lies just beneath the surface, waiting, still, to be seen? From the mysterious depressions concealed beneath the East Antarctic ice, we now shift to the continent's edge, to a place where the ancient meets the fragile, and where one of the most dramatic events in modern polar history has unfolded in plain sight. This is not a mystery buried under kilometers of frozen silence. It is one we have watched collapse in real time. Welcome to the Larsen Ice Shelf. Stretching along the eastern coast of the Antarctic Peninsula, the Larsen Ice Shelf once formed a massive frozen buffer between the continent and the Weddell Sea. It was divided into sectors, Larsen A, B, C, and D, each one a platform of ancient glacial ice, slowly flowing from the land and spreading out over the water like a frozen fan. But beginning in the 1990s, something strange started to happen. First, Larsen A disintegrated, breaking into massive shards and drifting into the Southern Ocean. Then, in 2002, Larsen B followed. In just over a month, an area of ice measuring more than 3,000 square kilometers, larger than Luxembourg, shattered into the sea. It was a sudden, almost surgical collapse. The shelf didn't melt slowly, it disintegrated. Icebergs the size of cities calved off in rapid succession. What had taken millennia to form vanished in days. And then, in 2017, Larsen Sea gave way to one of the largest iceberg detachments ever recorded, Iceberg A68. Nearly 6,000 square kilometers in size, it broke free and drifted into the Southern Ocean, reshaping coastlines, navigation patterns, and scientific expectations. But what caused such a dramatic unraveling? The leading theory is climate change. The Antarctic Peninsula is one of the fastest warming regions on Earth. Rising air temperatures, warmer ocean currents, and surface meltwater combine to weaken the structural integrity of ice shelves from above and below. Meltwater ponds on the surface seep into cracks and crevasses, deepening them and forcing the shelf apart, an effect known as hydrofracturing. Meanwhile, warmer seawater undermines the base, melting it from below. But in the case of Larsen B, scientists were stunned by the speed. Ice that had held fast for more than 10,000 years broke apart in a matter of weeks. What forces could cause such rapid disintegration? Was this an anomaly or a harbinger? Some researchers speculate that the shelf had been precariously balanced for centuries, and that small changes finally pushed it past a critical threshold. Others point to deeper mechanisms, such as shifting gravitational tides, the influence of atmospheric rivers delivering concentrated heat and moisture from the tropics, or even geomagnetic disruptions affecting sea ice dynamics. Could multiple factors, working in tandem, have created a perfect storm? And then, more speculative voices ask, did we truly understand what was beneath Larsen B before it collapsed? Radar surveys of the region prior to the breakup were limited. After the shelf vanished, researchers discovered previously unknown geological features, including submerged ridges, underwater canyons, and evidence of volcanic heat. Some wondered if geothermal pulses or crustal movements could have played a role, subsurface forces weakening the ice shelf from below, out of sight. Other theories, still unproven but persistent, suggest that the sudden collapse may have revealed or concealed more than just glacial movement. Could the retreat of the ice have exposed ancient landforms, or even fossilized ecosystems that have yet to be studied? Could the release of pressure from the collapse have activated deep-sea systems we are only beginning to detect, such as methane seeps or microbial colonies preserved in the cold? After the breakup, researchers quickly moved in to sample sediments from the now exposed seabed. What they found was unexpected: rare species of life, thriving in the absence of light, in ecosystems that had been hidden for over 100,000 years. Unique microbial communities, soft corals, sponges, organisms surviving in total darkness under layers of ice that had never before retreated in the age of human observation. What else may lie beneath other shelves, waiting in that frozen dark? Today, Larsen D remains intact, for now. But climate models suggest it may not hold forever, and each collapse raises a troubling question, not just for Antarctica, but for the world. Ice shelves act as buttresses for the glaciers behind them. When they collapse, the glaciers accelerate, pouring more ice into the ocean and contributing directly to sea level rise. The fate of Larsen isn't just about remote geography, it's about coastlines in New York, Mumbai, Lagos, and Shanghai. It's about how quickly sea levels might rise, and whether ancient systems we thought were stable are, in fact, far more fragile. Still, one cannot ignore the deeper sense of awe. Standing where Larsen B once held firm, one is struck not only by the scale of the loss, but by the silence it left behind. The still water where crevassed ice once groaned. The void that was once a shelf. It is a mystery in reverse, not a secret waiting to be uncovered, but one that has vanished before we could fully understand it. And so, the question remains, did we witness a natural progression or a signal? A warning of deeper changes taking place beneath the ice, unseen and unmeasured. And as other shelves begin to crack and creak, what will they reveal when they too fall into the sea? As we move from the crumbling edge of the Larsen ice shelf, where ancient ice vanishes into warming seas, we journey inward, deeper into Antarctica's stark and unforgiving interior. Here, in a place where even bacteria struggle to survive, another mystery emerges. Not beneath the ice this time, but lying silent upon it. Mummified seals, far from the coast, some over 50 kilometers inland. They lie in twisted, wind-sculpted poses, on rocky ground, not snow. Their leathery skin hardened by the freeze, their eyes long gone, their bones weathered by decades or even centuries of exposure. And yet, there is no water here, no fish, no prey, only barren rock and the coldest desert on Earth. Why are they here? These seal mummies have been discovered primarily in the McMurdo Dry Valleys, Antarctica's most alien landscape, an ice-free region where relentless katabatic winds strip moisture from the air and ground alike, preserving anything left in the open. The seals, some still bearing traces of fur, rest on high ridges and gravel plains. Many show signs of starvation, others of disorientation, but none are where they're supposed to be. Modern seals never stray this far from the sea. They are coastal animals, adapted for life on the ice edge. Their anatomy, their instincts, their lives, everything is tied to the ocean. So what drives them deep into the interior, where nothing lives and nothing grows? One explanation is navigational error. Some scientists believe that young or sick seals may become confused during storms, mistaking the gleaming white of frozen lakes or salt flats for distant ocean. They follow scent or sight inland, crossing increasingly barren terrain until exhaustion or starvation overtakes them. Once there, the freezing, bone-dry air preserves their remains in a process not unlike natural mummification, turning flesh to parchment and bone to relic. Others suggest magnetic disturbances may play a role. The dry valleys sit near known areas of magnetic variation, where the Earth's geomagnetic field becomes irregular. Could these fluctuations disorient seals that rely on magnetoreception for navigation? Could they be drawn not by mistake, but by instinct gone awry? But if it were simply misadventure, why are there so many? Over 100 mummified seals have been found in the dry valleys alone, and more continue to be discovered, sometimes clustered together, sometimes spaced miles apart. Some are less than a century old. Others, based on radiocarbon dating, are thousands of years old. Yet their condition remains eerily consistent. Some died alone. Others lie in what seem like purposeful positions, heads lifted, bodies curled, as if they had been seeking something. And stranger still, the remains aren't limited to seals. In rare instances, researchers have found what appear to be the bones of penguins far from shore, or the skulls of unknown animals partially buried in the gravel. Could there be ancient migration paths long erased by glacial advance? Were these regions once closer to the coast during a warmer time in Antarctica's distant past? Geological studies do suggest that the Antarctic coastline has shifted significantly over the last few million years. During periods of glacial retreat, marine animals may have ventured inland along now vanished inlets or river systems. But this doesn't fully explain the persistence of such mummified remains in more recent layers. And then, as with so many Antarctic enigmas, more speculative questions begin to surface. Some researchers have wondered whether these seal migrations are not just the result of mistake or drift, but of instinctual behavior. Could there be something about the dry valleys, something ancient and long encoded into biological memory, that draws these creatures here? Others point to seismic or acoustic anomalies detected in the region. The dry valleys hum with low-frequency vibrations, subtle, natural in origin, and often beyond human hearing. Could marine animals, sensitive to sound, perceive these signals as something meaningful? Could they be following an echo from the Earth itself? Still more fringe theorists entertain ideas of energetic hotspots, ley lines, or natural geophysical features that act like beacons, misinterpreted by animals as channels, pathways, or safe ground. These theories are, of course, unverified, but they grow from the same soil as the mystery, the sheer improbability of what has been found, and where. Why, in one of the most remote and lifeless places on Earth, do we find these frozen visitors? What did they see, or hear, or feel, that led them so far from home? The mummified seals lie still now, untouched by predator or scavenger, their bodies preserved by time and climate, their journey etched into the silence of rock and ice. And yet, they remain one of Antarctica's most quietly unsettling puzzles. Are they warnings from the past, natural anomalies, echoes of a shifting Earth? Or are they signs of something we do not yet understand, some unseen thread connecting land, sea, instinct, and ice? The dry valleys keep their silence. The wind howls across the stones, and the seal mummies wait, as they have for centuries, their faces lifted toward a sky that holds no answers, only questions. From the wind-scoured bones of mummified seals lying silent in the dry valleys, we turn now to another form of life, far smaller, far stranger, and far more resilient. Not a creature lost, but one very much alive, one that does not flee the cold, or the dark, or even radiation. In the shadows of Antarctica, buried within the ancient ice and stone, scientists have discovered fungi unlike any found elsewhere on Earth. Black, tenacious, and incredibly adaptive, these organisms don't just survive harsh conditions, they seem to thrive in them. And more remarkably, some of them appear to feed on radiation itself. It began with studies deep beneath the surface, inside the frozen rocks of the Transantarctic Mountains and the subsurface glacial crusts near Concordia Station. Researchers found colonies of melanized fungi, organisms darkened by high concentrations of melanin, the same pigment that colors human skin. But here, melanin serves a different purpose. In 2007, a parallel line of research on similar fungi, originally discovered in the irradiated ruins of Chernobyl, suggested that these organisms weren't merely withstanding radiation, they were absorbing it, using melanin not just for protection, but as a tool, as a converter, feeding on the energy of radiation the way plants feed on sunlight. Could it be that these Antarctic fungi do the same? Experiments conducted on the International Space Station later confirmed the potential. Samples of Cladosporium sphaerospermum, a melanized fungus similar to those found in Antarctica, were sent into orbit. There, they grew faster and healthier when exposed to elevated radiation, suggesting that ionizing radiation might be not only tolerated, but metabolically useful. A biological paradox, an organism that turns what is deadly into nourishment. On Earth, such fungi are rare. They live in places where other life cannot. Cracks in nuclear reactors, caverns miles underground, beneath glaciers, inside Antarctic permafrost. They exist where light cannot reach, and where conventional food chains fail. But what if this is not adaptation, but memory? Some scientists have speculated that these fungi may be ancient, far older than most forms of terrestrial life. They may trace their lineage back to eras when Earth's surface was more volatile, more radioactive, more extreme. Could their ability to feed on radiation be a vestige of a primordial world? A survival mechanism born in an age we can scarcely imagine? And in Antarctica, where ancient conditions are preserved like fossils in ice, could these organisms be relics of that time? So far, studies have focused primarily on isolated samples, colonies retrieved from exposed rock faces and frozen soil. But the possibility remains that much larger, Interconnected fungal networks exist beneath the ice, slow-growing melanized biospheres that tap into geothermal heat, cosmic rays, or even subtle background radiation as their energy source. If so, they would represent a form of life profoundly different from what we typically imagine. Not plant, not animal, not microbial in the usual sense, but something else, an organism that exists not in spite of extremes, but because of them. And then, as with so many Antarctic discoveries, questions begin to spiral outward. Could such fungi exist on other worlds? In the ice of Europa, in the dark rocks of Mars, or beneath the radiation-bathed surface of Enceladus? Could their resilience offer a blueprint for survival beyond Earth? NASA and other space agencies have taken notice. If life can metabolize radiation, it may not need sunlight or chemical nutrients to survive. It may live wherever energy exists, in whatever form. And that redefines our understanding of what is habitable. Closer to home, the idea of radiation-consuming fungi has even sparked speculation in more speculative circles. Could such organisms explain certain biological anomalies in extreme environments? Might they influence the chemistry of deep Antarctic lakes, where radiation seeps slowly through rock and ice? Might they even contribute to unexplained warmth or energy readings detected in subglacial regions? While no evidence yet points to anything beyond the microbial, the implications are vast. Because in these fungi, we are confronted with a different kind of life, not one that grows toward light or feeds in the traditional sense, but one that thrives in the invisible, one that consumes what we call dangerous, one that bends energy into survival in ways we do not yet understand. Are they simply the byproduct of billions of years of quiet adaptation? Or are they a glimpse of something deeper, a more ancient logic of biology hiding beneath the surface of the world? Antarctica, with its vaults of ice and stone, continues to yield surprises. Each discovery, whether a fossil, a void, or a fungus, reveals another layer of the unknown. And as we look more closely, we begin to see that life may be not just surviving here, but evolving along entirely different paths. What else waits in the cold? What forms of life feed on the forces we've only begun to measure? And in the frozen corners of this silent continent, how many more answers lie wrapped in darkness, patiently drawing strength from what the rest of life has always feared? From the black fungi that thrive on invisible rays of radiation, we now descend into the depths, into the frigid waters that encircle Antarctica like a moat of darkness and ice. Beneath the surface, in waters hovering just above freezing, drifts a creature so strange, so evolutionarily distinct, that it defies the very biology we take for granted. This is the icefish, pale, ghost-like, and astonishingly bloodless. Unlike any other known vertebrate, icefish of the family Channicthidae live without hemoglobin, the iron-rich protein that gives blood its red color and carries oxygen to cells. Their blood runs clear, their bodies almost translucent, and yet they survive and thrive in one of the harshest environments on Earth. How? Discovered in the Southern Ocean during the early 20th century, icefish have long puzzled biologists. In most animals, hemoglobin is essential. Without it, oxygen cannot efficiently reach tissues and organs begin to fail. But in icefish, hemoglobin genes have been lost or deactivated, broken fragments left behind like fossils in their DNA. These fish are not merely hemoglobin deficient, they are entirely devoid of it. So what keeps them alive? The answer lies, in part, in the icy waters themselves. Cold water holds more dissolved oxygen than warm water. And in the Southern Ocean, where temperatures regularly dip below zero thanks to high salinity and pressure, that oxygen is plentiful. Icefish have evolved unusually large hearts and wide blood vessels, allowing them to pump blood at high volume with less resistance. Their blood is thinner, flowing more easily through the body. Their metabolism is slow, their muscles oxygen efficient, and their organs finely tuned to extract every last bit of oxygen from their surroundings. In effect, they have adapted not to overcome the cold, but to work with it. But why lose hemoglobin at all? Some researchers suggest it may be an evolutionary trade-off. As Antarctic waters cooled dramatically millions of years ago, certain fish populations began to evolve in isolation. In a world with little competition and oxygen-rich seas, the energy cost of producing hemoglobin may have become unnecessary. Over time, mutations rendered the genes inactive, and the fish adapted to survive without it. Still, this doesn't explain the full picture. The absence of hemoglobin remains a biological anomaly, one that breaks the rules of vertebrate physiology. In no other vertebrate lineage has such a loss been observed. Why did this adaptation happen here and nowhere else? What environmental pressures or genetic accidents made it possible? And what other hidden mechanisms might support life in such extreme conditions? Icefish also produce special antifreeze proteins, molecules that bind to ice crystals and prevent their growth inside the body. Without them, their blood would freeze solid. These proteins are so efficient that they've inspired bioengineering and cryopreservation research worldwide. Their origin remains mysterious. Did they arise independently, or were they repurposed from older, more primitive proteins in the genome? Even stranger, some icefish species exhibit signs of vestigial red blood cells, tiny, inactive remnants of a lost function. Could they be evolutionary holdovers from a time when hemoglobin was still present? Or might they hint at a deeper, more complex metabolic strategy, one that is not fully understood? Beyond biology, these creatures raise philosophical questions about what life truly requires. Is hemoglobin essential? Is warm blood, rapid metabolism, or cellular oxygen transport the standard, or simply a path we've followed by chance? Could other forms of complex life exist with entirely different biochemistry, shaped by cold, pressure, and time? Could icefish be an earthbound example of a larger truth, that life is not only adaptable, but endlessly creative in its forms? Some scientists have speculated that the icefish's unique physiology might mirror conditions that could exist beneath the icy crusts of Europa or Enceladus, moons where oceans lie hidden, isolated from sunlight, yet warmed by tidal forces and rich in chemical complexity. If life exists there, would it resemble this ghost-like fish drifting through Antarctic waters? And more immediately, as Earth's climate changes and Antarctic waters warm, what will happen to the icefish? Their adaptations are finely tuned to an exact environment. Even a slight rise in ocean temperature could disrupt their oxygen balance, destabilize their antifreeze proteins, or bring competitors into a world they once had to themselves. The very trait that made them exceptional, living without hemoglobin, could become their greatest vulnerability. Yet for now, they endure. Pale silhouettes in the deep, drifting through water as cold and dark as the void of space. Their blood carries no color. Their hearts beat slowly. Their presence is quiet. But their existence speaks volumes. They remind us that evolution is not linear, that nature is not limited to what we understand, that even in a world of ice and darkness, life finds a way, not by resisting its environment, but by becoming something entirely new. What else swims in those depths, unseen, unmeasured, and just as improbable? What other biological impossibilities have adapted to thrive in silence? And as we study these clear-blooded creatures from the edge of understanding, we must ask ourselves, are we looking at a quirk of evolution, or a blueprint of something much older and far more universal? From the silent drift of translucent icefish gliding through oxygen-rich blackness, we now turn our attention not to what we can see, but to what we can hear, or rather, what we can detect. Because in the depths of Antarctica's frozen crust, something is calling, not in language, not in voice, but in frequency. Low, elusive, persistent. In recent years, researchers stationed across the Antarctic interior, especially those monitoring the continent's deep subsurface through instruments like radio antenna arrays, magnetic field sensors, and neutrino detectors, have reported a strange phenomenon: unusual electromagnetic signals, rhythmic pulses, faint, structured emissions rising from beneath the ice. Signals that, by all accounts, shouldn't be there. Some of these detections come from deep beneath the South Pole itself. Others have been traced to regions like Byrd Land, the Wilkes subglacial basin, or near buried mountain ranges like the Gamburtsev Mountains. In all cases, the emissions are real, recorded and verified through multiple instruments, and confirmed to be of non-astronomical origin. That is to say, they're not coming from space, they're coming from beneath us. What, then, is producing them? The first explanation lies in the complex interaction between Earth's magnetic field and the dense conductive layers beneath the ice sheet. Antarctica, after all, sits atop a dynamic geological base. There are known volcanoes under the ice, active fault zones, even regions of high geothermal heat, and the ionosphere above the pole is constantly bombarded by solar winds, producing auroras and magnetic surges that ripple downward. But these signals aren't random. Some have consistent frequency patterns. Others appear to rise and fall in strength with no obvious correlation to solar or seismic activity. A few have been described as structured, repeating at intervals too regular to be dismissed as mere environmental noise. In some cases, they've lasted minutes. In others, hours. And what's most curious of all, some seem to move. Detectors positioned kilometers apart have captured signals that sweep across the ice in a slow, deliberate arc, suggesting a source in motion. But what moves beneath the Antarctic ice with that kind of electromagnetic footprint? What transmits through solid rock and frozen water with such persistence? Could it be the shifting of ice sheets themselves? The grinding of glacial masses against the continent's bedrock? Possibly. Some researchers believe the electromagnetic emissions may originate from triboelectric effects, static charges generated by immense, slow-motion friction beneath the ice. Others point to the possibility of water, subglacial lakes draining or shifting under pressure, generating piezoelectric effects as minerals are compressed and released. But none of these theories explain the regularity of certain signals, nor their origin points in some of the deepest, coldest, and geologically quietest parts of the continent. This has led to more speculative thinking. In some corners of Antarctic research, there are whispered questions about the presence of vast underground cavities, voids warmed by geothermal energy and perhaps isolated from the surface for millions of years. Could something within those voids be producing electromagnetic activity? In 2018, scientists with the ANITA project, the Antarctic Impulsive Transient Antenna, detected upward-moving, high-energy particles that seem to defy standard models of physics. While these are not the same as the deep EM signals, both anomalies point to one recurring theme: that Antarctica may hold physical phenomena we don't yet fully understand. And then, of course, come the fringe theories. Some claim these signals are artificial, emanating from something built deep underground. They draw connections between the signal sites and ancient crater-like structures, or magnetic anomalies mapped decades earlier. Others go further, suggesting remnants of lost civilizations, buried technology, or the remnants of non-human intelligence encased in the ice. There is no scientific evidence to support such claims, but their persistence reveals something deeper, a growing recognition that Antarctica's silence is not emptiness, it's potential, a blank canvas where mystery still lives. More grounded researchers are turning to new technologies to dig deeper, literally and figuratively. Networks of ultra-sensitive sensors are being deployed to monitor electromagnetic activity in real time. Ice-penetrating radar is being refined to image not just terrain, but conductive properties beneath the surface. The hope is that with more data, the signals will begin to make sense. But for now, they remain a riddle. What kind of natural process could emit structured, mobile EM signals from beneath kilometers of ice? Why do some seem to repeat, faintly but clearly, across multiple seasons and regions? And why are they found in places where, by all our models, there should be nothing but frozen rock? In Antarctica, what we don't hear may matter more than what we do. These quiet pulses from the depths don't scream for attention. They hum, whisper, repeat. And as they pass through stone and ice, undisturbed by time or witness, one is left to wonder, are they a signature of something ancient and still alive in the Earth's crust? A voice from the planet itself? Or something else entirely? An intelligence we've yet to recognize, patiently reaching out in the only way it knows how. Whatever the source, one thing is clear. Antarctica still speaks, and the ice is still listening. From the quiet, drifting signals that rise from the depths of Antarctica's ice, we now descend further still, into the strange and secret world that lies hidden beneath it. A world not of frozen rock, nor silent void, but of liquid, flowing, ancient, and impossibly warm. These are Antarctica's under-ice lakes, bodies of liquid water trapped beneath kilometers of ice that do not freeze. In one of the coldest places on Earth, this should be impossible. Surface temperatures regularly plunge below -50 degrees Celsius, and yet, beneath the weight of the East Antarctic ice sheet, over 400 subglacial lakes remain liquid, undisturbed by light, isolated for millions of years, and suspended in a delicate balance of heat and pressure. Among them, Lake Vostok is the largest and perhaps the most enigmatic. Buried beneath nearly 4 kilometers of ice, it spans over 250 kilometers in length and remains one of the most pristine aquatic environments on Earth. Discovered in the mid-1990s through satellite altimetry and radar imaging, Lake Vostok challenged every assumption scientists held about the Antarctic interior. How could such a massive body of water remain unfrozen in such a hostile environment? The leading explanation involves geothermal heat. The Earth's crust, even beneath Antarctica, radiates warmth, and the immense pressure exerted by the ice above lowers the melting point of water, allowing it to stay in a liquid state despite the frigid temperatures. Add to that a thick insulating shell of ice, and the result is a perfect storm of physics, a lake that never sees the sun but refuses to freeze. But the mystery deepens. These lakes are not stagnant. Some show signs of active hydrological systems, connected by hidden rivers that flow between basins, carrying water and perhaps life beneath the ice. Others exhibit strange chemistry, anomalous levels of gases like methane and nitrogen, high concentrations of salts, and traces of ancient minerals. In a few, organic compounds have been detected. Could life exist here in total darkness, fed not by sunlight, but by chemical reactions? When Lake Whillans was successfully drilled and sampled in 2013, the results were astonishing. Researchers found microbial life, alive, metabolizing, reproducing, in the icy water. These weren't just dormant remnants from another time. They were thriving, feeding on carbon and sulfur compounds locked in the sediments, operating in a biosphere sealed from the atmosphere for thousands, perhaps millions of years. What else might be waiting in these hidden lakes? Lake Mercer, drilled in 2019, yielded similar findings: active microbes, strange chemistry, and evidence of complex interactions between geology and biology. The microbial ecosystems here seem to operate on their own terms, shaped by slow-moving currents and underground geochemical cycles. But not all lakes have been reached. In fact, most haven't. Some remain completely untouched. And then there are the more peculiar features. Lake Vostok, for instance, exhibits odd magnetic anomalies, regions where the Earth's magnetic field behaves strangely, concentrated above certain parts of the lakebed. Some speculate that metallic sediments or geothermal features might be the cause. Others wonder if something more unusual lies beneath the ice. A few fringe theories, unproven but persistent, suggest that the lake may conceal long-lost evidence of ancient ecosystems, even pre-human civilizations. The near-perfect isolation, the strange geomagnetic data, and the immense difficulty in accessing it have all contributed to the mythos. A place preserved in time, untouched for millions of years. If anything ever had lived in Antarctica when it was a green, forested continent, might traces of that life still lie buried in these lakes? There are logistical and ethical barriers to answering that question. Drilling into a pristine environment runs the risk of contamination. Each attempt must balance scientific curiosity with the preservation of an untouched system. And so, many lakes remain unexplored, not because we lack the tools, but because we hesitate to disturb what may be one of Earth's last natural laboratories. And there's something else. Recent satellite data and radar studies suggest that some under-ice lakes are not stable. They rise and fall, draining and refilling in sudden pulses. In 2007, NASA scientists observed the surface above one such lake drop by several meters, an indication that massive amounts of water had shifted, flowing through unseen channels beneath the ice. The scale of these movements was staggering. Billions of gallons of water, moving beneath a continent we long assumed was static. Where is it going? And what might it be carrying with it? Could these networks of subglacial lakes and rivers form a kind of hidden circulatory system, connecting deep parts of the continent in ways we can't yet see? Could they transport not only water, but life, or sediment, or the chemical history of an Earth we've never truly known? And how long have they been doing it? Antarctica was not always frozen. Tens of millions of years ago, it was temperate, home to ferns, dinosaurs, and forests. As the climate cooled and the ice spread, it sealed away the past in layers of snow, then ice, then silence. But the lakes beneath may still remember. They may still carry whispers of that ancient world in every drop. And so we ask, are these under-ice lakes merely scientific oddities, products of geothermal heat and pressure? Or are they portals into Earth's deep history? And perhaps, if we're careful enough and patient enough, might they one day offer a glimpse into forms of life, cycles of climate, or even lost epochs that we thought had been erased forever? Antarctica's ice covers many things, but some of them still move, some of them still breathe, and some of them may still be waiting to be found. From the veiled networks of under-ice lakes, where water flows in silence and time stands still, we now turn to something even more volatile, something invisible, trapped not in caverns or basins, but in bubbles sealed tight beneath ice and sediment, locked away for millennia, waiting. This is the mystery of Antarctica's subglacial methane. Deep beneath the east and west Antarctic ice sheets, scientists have discovered vast reservoirs of methane, an odorless, colorless gas with the power to shape the planet's climate and perhaps reveal something ancient about the land below. These reservoirs don't announce themselves with visible plumes or surface scars. Their presence is betrayed only by chemistry, subtle shifts in ice core samples, faint signatures in atmospheric readings, and the hidden language of isotope ratios. Methane is common on Earth, but rarely in this form, and never in such silence. Most methane on the surface comes from biological sources, microbes digesting organic material in wetlands, decomposing matter, agricultural processes. But beneath Antarctica's frozen crust, the methane is sealed away, entombed in ancient sediments, trapped in icy cages of crystal, called clathrates, or dissolved in subglacial lakes in forms not yet fully understood. How did it get there? Some of it may date back tens of millions of years, trapped as Antarctica transitioned from a green, forested continent to a frozen desert. When ancient wetlands and shallow seas were buried by glaciers, their organic material was sealed away. Over time, pressure and microbial action converted that material into methane, and the advancing ice locked it in place. Other reservoirs may still be forming. In several regions of West Antarctica, especially beneath the Willans and Mercer ice streams, scientists have found sediments rich in carbon and teeming with life, microbes that feed on hydrogen, sulfur, and carbon compounds, producing methane in complete darkness. These ecosystems, isolated from the surface for hundreds of thousands of years, continue to function in the absence of light, oxygen, and seasonal cycles. And what they're producing is building up. Estimates suggest that Antarctica may contain hundreds of billions of tons of carbon trapped beneath its ice, much of it in the form of methane or organic precursors to it. If released, it could accelerate global warming with staggering speed. Methane is over 25 times more effective than carbon dioxide at trapping heat in the atmosphere. A large-scale release would not be a slow unfolding. It would be a tipping point. But the danger is not immediate, not yet. The ice remains thick, the pressure stable, and the methane, for now, is locked away in its crystalline prisons. But the equilibrium is fragile. Climate change is already altering the outer edges of Antarctica. As glaciers thin and ice sheets retreat, subglacial basins warm. Some lakes have begun to drain. Some sediments have begun to shift. The question is no longer if the methane will be released, but when, where, and how much. Yet the mystery is not just one of climate, it is also one of life. What kind of organisms survive in these dark, pressurized systems, feeding on rock, breathing chemical energy, and producing methane in total isolation? Some of the microbes recovered from drilling samples in Antarctica share similarities with extremophiles found at deep-sea hydrothermal vents and beneath the Arctic permafrost. But others are more unusual, genetically distinct, metabolically novel. They may represent ancient branches of life's tree, survivors of Earth's early biosphere, thriving in environments that mimic the planet's distant past. Could they be analogues for life on other icy worlds? Mars, Europa, Enceladus. If methane is being produced now in the dark beneath Antarctica, what might that say about methane detected on Mars, where plumes appear and vanish in cycles we don't yet understand? And then, deeper still, lies the question of methane's origin. Not all of it is biological. Some methane may form abiotically, produced by chemical reactions between water and rock, deep within the crust. These processes hint at geothermal forces, tectonic heat, and interactions still active beneath Antarctica's ice. Could part of the methane signature point to geological activity we have not yet mapped? Could shifting reservoirs of gas be a sign of deeper forces at work? In a few regions, magnetic and gravitational anomalies align curiously well with suspected methane sites. Some suggest a connection between geothermal heat, crustal movement, and gas migration. Others point to the possibility of unknown volcanic activity, or the remnants of ancient hydrocarbon systems now buried in silence. And then, of course, there are more speculative questions. Could the methane reservoirs hold more than gas? Could they preserve ancient DNA, fragments of life from a time before the ice? Could they conceal microorganisms with metabolic pathways never before seen, or chemical signatures that rewrite our understanding of the deep biosphere. So far, we have only scratched the surface, literally. Most methane deposits remain sealed, undisturbed beneath kilometers of ice. Sampling them is a delicate process. One wrong move, and a release could contaminate both the ecosystem and the data. And so, we wait. We monitor. We model. We imagine. Because these reservoirs are not just a threat. They are a message from the Earth itself. A record of ancient climate, ancient life, and ancient carbon held in suspension. What happens if that record is broken? What might we learn from what escapes? And what, still sealed in the cold, remains hidden, waiting to be found not in fire or flood, but in a breath of invisible gas rising one day from beneath the ice? The ice remembers. The pressure holds. But the Earth, even here, is alive. From the silent pressure of methane sealed beneath layers of ice and time, we now turn our attention to something smaller, quieter, and infinitely older. Not a gas, nor a signal, but life itself, or what may remain of it. Frozen deep within Antarctica's ancient ice, embedded in layers compacted over geological epochs, scientists have discovered something remarkable. Tiny structures, fragile fragments, microscopic organisms preserved in suspended animation for up to 500 million years. 500 million. These are the strange remains, or perhaps the dormant echoes, of ancient life forms found in the deepest sections of Antarctic ice cores. Extracted with the utmost care from depths of over 3,000 meters, these cores are more than cylinders of frozen water. They are scrolls of Earth's past, each layer a page, recording atmospheric changes, climate shifts, volcanic eruptions, and, sometimes, the faint traces of life that once drifted through ancient skies or swam in long-lost seas. Among these traces are simple microbial forms, cyanobacteria, diatoms, spores. In some cases, even cellular structures whose origins stretch back to the Cambrian period, more than 500 million years ago, when complex life on Earth had only just begun to bloom. How did they get here? Some may have been carried on the wind, dust particles lifted into the stratosphere and deposited over Antarctica during ancient global events, volcanic eruptions, meteor strikes, or massive climate shifts. Others may have risen from below, caught in upwellings through cracks in the ice, remnants of long-buried ecosystems now erased from the surface. But their preservation raises deeper questions. These microorganisms are not fossilized. In many cases, their structures remain intact. Membranes, pigments, even DNA. Fragmented, yes, but present. Some researchers believe they may not be entirely dead, that under the right conditions, they might stir again, reanimate, divide. Could they still be alive, locked in metabolic dormancy for hundreds of millions of years? In 2000, a team of scientists successfully revived bacteria from an ice core believed to be over 120,000 years old. Later studies extended that timeline further, reviving spores from permafrost and glacier ice dating back over 750,000 years. These ancient microbes resumed growth when exposed to warmth, nutrients, and moisture. If such resilience is possible in known extremophiles, what about the enigmatic organisms found deeper still? And what if some of these life forms are not like anything we've ever seen? Certain samples have yielded microfossils that resist classification, structures that resemble no known bacteria or algae, unusual lipid compositions, curious genetic sequences. Could they represent extinct lineages, ancient domains of life that never made it to the present? Or perhaps ancestors of modern microbes, frozen at a crossroads in evolution, suspended just as complexity was beginning to take hold? The implications are staggering. These organisms offer more than just a glimpse into ancient biology. They are a time capsule, one that spans mass extinctions, tectonic upheaval, even the birth of modern ecosystems. Studying them may reveal clues about Earth's early atmosphere, its primitive oceans, and the delicate balance that allowed life to emerge. But there is another, more speculative layer to this mystery. If life can survive for hundreds of millions of years, dormant, hidden in ice, what does that mean for other frozen worlds? Mars once had water. Europa and Enceladus still do. Could similar microscopic life exist there, waiting beneath ice crusts in dormant silence? Could organisms from Earth's Cambrian oceans resemble life that might exist, or once existed, on those distant moons? In fact, the parallels are more than poetic. Antarctica, in many ways, is Earth's closest analog to these icy worlds, and its ice cores are our first and best glimpse into what happens when life meets deep time. But not everyone agrees on what's been found. Some scientists urge caution. Contamination is always a risk. Ancient ice cores are notoriously difficult to handle without introducing modern biological material. Are we studying Earth's past, or ourselves? Are the anomalies genuine, or artifacts of the tools used to find them? Even among believers, there is debate. Some argue that the organisms are relics from shallow seas that once covered parts of Antarctica before the ice came. Others suggest they were deposited from the upper atmosphere during turbulent, ancient epochs. A few wonder if subglacial lakes, isolated for tens of millions of years, might harbor still living communities from which these ancient microbes have escaped. And then there are the deeper, more haunting questions. Could these organisms, long dormant, possess genetic traits unknown to modern biology? Could they interact with modern ecosystems in ways we can't predict? And are we prepared for what might happen if, in our search for knowledge, we awaken something meant to remain asleep? No one knows. For now, the organisms remain under study, kept in sealed labs, examined under microscopes, sequenced and scanned. Most show no signs of activity, but even in death, they speak. They tell us of a world we have never seen, a time when continents were still drifting into place, when life's great experiment was just beginning. And yet, they are here, beneath our feet, preserved in ice so clear it looks like glass, whispering of oceans that no longer exist, skies that once held different air, and creatures that have long since vanished into the dust of time. What else lies locked in that ice? What other histories remain unread? And when we finally reach the oldest layers, the deepest cores, will we find not just evidence of life, but something far more complex, something that still waits to be named?